Hello? Oh, great. So sorry about this. So I think I always have trouble with Restream. Yeah, so I'm glad that got resolved as fast as possible. Um, so it's been a long ride over the last couple of days, and finally today is the last day of the AsyncAPI Conference 2022. And yeah, so I'm so excited. Over the last couple of days, we've had you know amazing folks come on stage, and we've had so many interesting presentations from various people from the community, and also from various people that are actually using the some of the tools in the Async API ecosystem. And yeah, so since today is the last day, before I start, I would love to give out a shout out to all the people that made this conference possible, which includes amazing folks from the community. A special shout out to Lukash. So we have Ben, we have Karuna, we have I don't know, I can't keep going on because the list is so long. And special shout out to Alejandra and Babanos, of folks that made this conference so interesting. And also, I'm giving a special shout out to our sponsors, which includes Postman, which is the SNKPI Platinum sponsor for Conference 2022, and also Ably, which is a gold sponsor for this conference. And yeah, so why not? Let's get right into it. So the first person for this presentation, for the first person presenting today is our own very star, which is Karuna Tata. So I'm bringing her up stage. Karuna, are you ready? Okay, so coming up stage now is Karuna. So hello, Karuna.
Hello, hello.
How you doing?
I'm doing good and really excited for today.
Yeah, same here. I'm so fortunate to be the one hosting you because I know you've done so many amazing stuff with the community, and yeah, so I'm so excited for you to get started. Do you have anything to share before we get right into it? Would you like to say anything?
Um, yeah, do enjoy the last day of conference, and we might have some surprise for you, which we did yesterday, but today might be different. So keep an eye
Yeah,
out
she
for
said.
that.
Yeah, absolutely. She said we might, so don't get your bars raised, okay? So we might not. So who knows? So yeah, so why not? Let's get right into it. Karuna. So oh boy, Karim.
Hey everyone, it's so good to see you at AsyncAPI Conference. I am Karuna and my topic is Let Me In, open the doors of your organization for student contributors. Let me just quickly introduce myself. Hey, I'm Karuna and I am a coach at Major League Hacking and a technical writer at AsyncAPI and as a part of GSOD. GSOD is short for Google Season of Dogs, and I have been contributing to a CGAPI apart from GSOD too. And I have been part of multiple student communities and open source organizations. Also, I have done lots of events in the past, and I have been like streaming on YouTube, doing like uh, lots of podcasts and Twitter spaces. And fun fact, I like drawing anime characters. Now, before we get into the real part of the session, let me ask you one question. What is open source? Now, I think a lot of you might know what is open source, but still, let me explain. You can see this meme right here saying open source programmers and they are just lifting up the society. Now, what does that mean? Uh, I'll say because we might be using a lot of open source tools. You might even like not know about it. Let's say there is Firefox, there's VLC editor, video editor, and there are a lot of tools, right? And all these are developed by open source contributors and open source maintainers. Now, if you want to become this open source programmer who's lifting up the society, what I will recommend is contribute to open source. Now, you will say, why should I contribute to it? Just because, like, I do not want to be a hero, I'm fine being a normal person. Then you might want to reconsider that because it helps you in a lot of ways. Let's say you are using an open source tool and it keeps on crashing and you might be wondering why, and you can do a great job by reporting bugs on GitHub issues. Let's say VLC has its own repo on GitHub. You can just head on if it crashes sometimes or you see some issues happening on VLC. You can just go on to the repo, raise an issue, and that issue will be fixed in no time because a lot of contributors and maintainers see those issues, keep track of it, and those issues won't be like that. Like closed source, what happens in closed source is if you wanna report a bug saying that hey, my Google Chrome keeps on crashing, but you can't see the code of Google Chrome, and you just have to send a report to them saying it keeps on crashing. Now you don't know how much time it will take for them to ship the next patch because only few people will be working in that group. So in GitHub, in open source, you don't have to do that. You can just go on to the repository and like say there is a bug, and then making meaningful contributions to open source software. This leads to like elevate your skills, and you can make it better. Like let's say if I know Python and I wanna contribute to Python related software or tools, i I might not know some concepts, and then I go on discover some concepts in the repository, and I will ask, hey, how can I do this? They to the maintainer, and the maintainers might reply, hey, you can check out these resources you have, and then I will learn that concept, and then I will make my contribution go live, right? This can be a great opportunity to put your skills and see that you can grow a lot more in open source. And also this puts your work in public, like open source is viewed by everyone, right? So whenever you are contributing to an open source, you can see that these are my issues, these are the pull requests, these are the files which I changed, or this is the code. You can also show it to your job you can also show it on your job resume, or you can show it to your HRs, or any technical interviews. You can just say, hey, I have done this before. So this helps you a lot. And then getting started in open source is a great way. So one thing I'll tell you, if you have never ever contributed to open source, you can just do fixing typos. Like lot of open source contributors who are maintainers now or GitHub stars now started somewhere, right? Even I started somewhere. So you might be thinking they are already great, they know so many things. It's not like that. Everyone gets started at some point. So fixing typos in documentations or readmes or in code, if you see it, you can just like ship a pull request, and that's a great way to get started. You will know how git works, github works. You will like collaborate with others saying, hey, I made this. You will get to know like how to comment, what languages you should use, what are the do's and do nots. So you can just go ahead and do that. Now, I'll be talking about some problems which I see where students face while contributing to open source projects. Let's say one student like done everything, like they did fixing typos or finding good first issues and doing it, but they still find it hard, like not finding right projects to contribute to. So these are some questions which I get on daily basis, or let's say this is just repetitive questions which I get every time from all of those students. So tell me, how did you get into open source or communities? Beginner friendly projects are not really friendly. And then what language did you learn? So how did you get into open sources? Just by getting into it. uh, I mean, once you get started in it, start having conversations with them in Discord or in Slack or whatever platform the organization uses. let's say I'm contributing to Async API, and in the start I might not know what conversation to start. So I might pick an issue which is labeled as good first issue, and then I will contribute, make a PR to it, and they might say, hey, these are the changes, and the conversation goes on. And what you can do is you can just hop onto the Slack or Discord and start a conversation saying, hey, I fixed this PR, but do we have any more issues, or do we have anything else where I can contribute to? If you are into design or if you are into code, they have everything for that. So that's not a problem. And then beginner friendly projects are not really friendly. Yes, I have seen those projects. And I mean, if you look from the point of view of a beginner where you don't know code or you don't know how to like talk to maintainers or comment out or something, then you might see this big repository with lot of files, folders, and all of the code everywhere. And you might find it really difficult to do that. But let me tell you one thing, even if you see a really big repository with lot of files, folders, and stuff, you can just go on to uh, picking up like good first issues and see that there might be few comments already left by the maintainer saying that this is a good first issue and this can be solved in this way. Even if you do not get how to solve it, you can just comment there that I am stuck here. Will you please tell me how to solve this part, right? And what language did I learn does not matter really, because each and every organization has its own language, own tech stack. So um, I'll say that when you are picking a project, or if you are just really interested in doing that project, then you might have to learn the language, or you might have to know the concepts which you already like know in other language, and then convert it to, let's say I know Python and I want to convert these concepts which I learn in Python to JavaScript because I'm contributing to a project with JavaScript right now. So these are some changes you might have to do it, because if you want to contribute it, you have to make sure that you know everything regarding to that project. And solution for this, as I mentioned, good first issue and Hacktoberfest labels. If you don't know, Hacktoberfest is a month-long uh, open source program where anyone can come and contribute to open source, and they have projects listed out there on their website. And then you have to just make uh, 3 pull requests, and you get swag as in t-shirts like this, or anything regarding to that. So if you do a contribution to an open source organization with Hacktoberfest label, then you get swag, and that's a great motivation for you to get started. And here's a comment of Async API from someone from Async API saying that they don't mind having a contributor doing that issue or giving that pull request. So this is also a great way to make your organization inclusive. Like every time a maintainer comes and says, no, this issue is only done by the core people, or this issue is just meant for these people and you are not welcome to do it, that makes your organization not very inclusive and closed. So it just looks like a very exclusive organization. And as you can see in the comments, so the they don't mind having a contributor do the work for them if they want to, and this makes it really amazing to look at. And then we have few more resources listed out here, which is upforgrads.net. So this repository is meant for new contributors only, and you can see all the issues or repositories where they have uh, things for new contributors to get started in open source. And then first timers only is another resource just like up for grabs. You might want to check it out and do Hacktoberfest because it's still going on. And as I speak, Hacktoberfest is like half completed. Some people might have even gotten mail saying that, hey, your 3 pull requests are merged. So if you are still not doing Hacktoberfest, go join it right now. Here's another meme. So all your open source contribution is type of pull request, but This helps a lot because some typos do not look good in any code or in documentation, so it's still a valid um, open source contribution. Another problem which I see here is organizations not being inclusive, just as I talked in my previous slide. So you can see here are a few organizations which I find really, really inclusive. One is EduHub community. This is really inclusive and like they also promote speaking inclusive language in their own Discord server. They had a bot actually where um, if you write some non-inclusive language, the bot flags you out and says, "Hey, this is not inclusive." And once you edit your message, the bot message goes away. It's I really like that bot, and it makes people like get used to it. Once, let's say I make mistakes twice saying some non-inclusive language, and the bot flags me out 2 times, 3 times, and like fourth time I'll get used to it, like slowly saying, "Oh, yay! I learned inclusive language," and I'll start using it everywhere, regardless if the bot flags me or not. I'll still use it everywhere. Also, here are a few another comments saying that some contributor contribute like come and say, "Can I work on this issue?" And they say, "No need to ask for my permission, you can just go ahead." This is like really great way to make contributors welcome in your issues or like that. And then I had a contribution. I was making contribution to Async API, which is like the issue was outside of GSOT program, and I wanted to contribute to it because I found it interesting. And then they were getting started there, making the ambassador program page. So I wanted to make that page correctly, and I did what I like understood uh, from previous TSC page. So I just copied, pasted it, and then changed few context or text. And then people started giving on reviews one after the other, saying that, "Hey, this could be like that," and other maintainers hop on and say that, "Hey, if you don't know how to do it, would you like us to show to you? Like, would you like to hop on a call and show it to you?" They help us a lot, saying this like makes a contributor feel welcome, and at the same time it does not make a contributor feel like they haven't they don't have the knowledge or they can't contribute to it. So this is a great way to say that a maintainer of an organization saying that we will help you even if you don't know. We have people who can help you. Here are the mentors, or here are like people who can guide you into this stuff. That's a great way to make your organization inclusive. And another problem I see is losing motivation or direction. So, where does this come from? Losing motivation or direction. So, we all know that open source is voluntary, right? So people just come and do it. No one's getting paid for it, or no one's really taking it very, very seriously. Like it's not their full time job. It should like it should be great if open source was full time job, but it's not like that. People have their bills to pay, and for most of the people I know, it's not a full time. So they just do it for community, or they just do it for their projects which are running on, right? So as for students, we have lot of things to like focus on. We have academics, we have open source work, and we might have some other coursework, or we have to like get 10 on 10 on in every subject and then graduate or look for jobs. So there are a lot of pressure on students. So in this, open source might just go in a side and sit there, and we might not even think about it anymore. So uh, like what makes us lose this direction is all of these pressures. And what can we as an organization do to help these students make a proper contribution, and then also cheer them up as a motivation? Here's the solution. again few memes saying that we might buy a $3,000 laptop, but $5,000 open source donation is like, no way, I'm not doing that. And open source developers do not get paid. They might be contributing to a lot of stuff and uh, making your tools better and better, but they do not get paid. And this way, like, we lose motivation to do that after some time, because we have jobs which pay us. Then why would you do open source, right? For students, I'll say swags are some kind of motivation. Let's say they get stickers, or let's say they get t-shirts. After some point of time, those things are a little meaningless, and then we come to a point where we have to look for our jobs or pay our bills. Or if some student wants to do a course, they might want to pay for it, but they do not have the right resources or things to pay for it. So GitHub Sponsors is such program where you can sponsor a student if they are doing a really great job in open source, and this will help them in a lot of ways, right? And also, there are some programs like GSOD where your organizations like AsyncAPI hire technical writers, and then Google pays them at the end of the time period, so that they can just come and say that we contributed here, and then Google pays them, right? This is a great way. And another thing is we have Google Summer of Code, which is similar to GSOD, but it's not about documentation, it's about code. So you write a proposal to the open source organization and to the project saying that, hey, I can help with this. This is the feature I propose, and if you get selected, you can start with your code contributions, and you can learn a lot of skills. You can make a lot of connections, networks, and then in the end you get paid. So this also helps you in the job perspective, plus you can pay your bills. So this is a great way. And there are a lot of other programs where you get paid. So if you might want to explore it, you should. Because, and as I told, that GitHub sponsors is another great way where if you think someone's doing good, you can just go on and sponsor them. This little donation will help them a lot in growing, right? And if you are wondering, after hearing all these problems and solutions, saying, how can I bring the change to my open source organization? Like, how can I be inclusive? Uh, it's not really hard to do it, because once you start adapting to the ideas, then your organization will grow in no time, and you'll get a lot more contributors than you do today. So first point, add a code of conduct. Now, code of conduct clarifies organization's mission and vision, and it also tells you that this organization is a safe place for everyone, and it shows that the standards of professionalism. Also, it articulates the values of your organization, and so it tells all the contributors that this is the desired behavior, and if you go out of it, you might not get to contribute to open source. So uh, code of adding a code of conduct is a great way to tell people about your open source organization, and also to make contributors aware that if someone goes out of their way and like violates code of conduct, we will take action against them. So that, and eradicating problematic language from open source code and documentation. There's an article by Red Hat where they say that the problematic language is becoming non-inclusive for everyone, and they should remove it, and they are taking action on it for, like, in code and also in documentation. So this makes our organization more inclusive. Next is ask, don't tell. This is for contributors and also maintainers. Let's say you should not tell people something to do. You should just ask them or request them politely, saying that, hey, I made this pull request. If you are like this, if this is a valid contribution, could you please merge it? This is not the right way of asking, saying that, hey, merge my pull request. Hey, merge my pull request. Or they can just spam your comment section by saying, hey, merge, and that's not a great way. So you don't tell anyone to do. You just ask them so that you will get reviews on it or you get feedback on it, saying next time you can do better, or next time you can use like contribute on this issue, and you get feedback like that. So, and another thing is being specific. Now, this helps in a lot of ways, because one thing I see is if you are not specific, people might get confused. Let's say I have a problem regarding something ABC, and then I might just text the maintainer, or just hop onto the Discord server and say, uh, hey, I made this PR. Could you help me out? This is a really vague way to put your problem out there. So you should be specific in defining what your problem is. So when you hop onto Discord saying that, hey, this is my PR, link the PR or say the PR number. And then you come to the point where I'm stuck at this point. I do not understand this. You can be very specific. This saves the lot of time of you and the time of the maintainer, like, or any mentor who guides you, right? So if you are specific, you get the solution to the proper thing where you are stuck at. If you are not specific, then you might get a vague answer just like that, or they might not even uh, make an effort to solve your problem. Then next is explain yourself. If you are making a pull request, then you should know that you can paste before and after screenshots if it's a code or documentation contribution, or if it's a UI UX design contribution, then you can explain what you have done properly in a great way, so that this helps in merging PRs very quickly, and this makes the work of the maintainer easier, right? And offer solutions. If you see an issue which is like stuck from a very long time and you know how to solve it, offer them saying that, hey, I worked on the same problem last time, or I did a PR similar to this, and link the PR, or write like, I have written a blog on this problem. I think I can help you, and then say you can do XYZ steps. And they might give you a chance to like contribute to their organization, and it might end up being a great contribution to the organization, right? And then have diversity. I like this point of in AsyncAPI, where like when I was interviewing for my GSOD, and I saw the document of the, like, in the GitHub repo they wrote, we do not want to be a barrier for any of the technical writers, and everyone is welcome to interview. They got 200 applications, but still they like did not leave the applications in between saying, oh, they won't make it, they won't make it, and they did not do that. They took all the interviews of 200 people, and it's very diverse community. Let's say like I'm coming from some different background, and some other contributors are coming from a different background. So it's just not like everyone's like great at technical writing, or they have a PhD degree or something. We came from very different backgrounds, and then they sort, so this diversity uh, makes community very inclusive. And also I would like to mention that AsyncAPI did not let other contributors who like interviewed for this sort go away. They said they have another program called mentorship session. So once the GSOD interviews were over and technical writers were selected, they launched another program for mentorship, and saying that the other people who did not get into GSOD, they can check out these mentorship program which we launched, and they can still contribute to it. Right? This is a great way to keep your contributors in your organization. And then setting up a wiki or repo where people can contribute their ideas or offer suggestions. Nowadays, people don't use wikis much, I think. but there is a feature called discussions by GitHub. So if your organization have a discussions tab, please make sure you use it properly, because many contributors can come and leave their ideas or suggestions. Let's say you start a discussion saying AsyncAPI conference. Now you will see like many of the contributors commented and shared their ideas and saying that this time works, this does not, or they just gave to make this event a success, gave ideas to make this event a success. So that is also a great way to make your contributors keep getting involved in your organization. And then thank you for listening to my talk, and ending with a small meme: fixing app breaking bugs versus fixing typos in documentation. You get started with fixing typos in documentation, and there's no shame in it. Like, you can just go ahead and do that one. You can just find one typo in a sync API repo already and then fix it. So you can get started in open source right now and right here, right? So thank you so much, and bye.
Hey, Karuna, you there? So what an amazing presentation from Karuna. So I can see we have a couple of questions for Karuna, and yeah, so I'm checking if Karuna is there. Karuna, are you ready to come up stage? Okay. Yeah, what an amazing presentation, Karuna. So enlightening that even me, I get to learn a lot of amazing stuff from the talk. And yeah, we've got a couple of questions for you from the audience. So the first question is from Elegbedi Aziz. He said, a common misconception about contributing to open source is that you need to start contributing code. In fact, it is often that the other parts of a project that are most neglected and overlooked. What advice will you give other types of contributors?
So my advice is open source does not limit just to code. Uh, you can go beyond code. As you can see, we are doing documentation at AsyncAPI. I have seen people who contribute to design too. We have Barbano, who you might have seen in AsyncAPI Slack doing design contributions, and we have people who do community management. Even though being a project manager at open source is also a contribution, and other types of contribution include open source advocacy. So if you are going out to give a talks like this, uh, that is also a contribution because you are educating people about open source. So this is another contribution I see. So these are my advices. If you are new to open source, do not back away just saying it's only for code. You can contribute in many ways, even if it's not code.
Awesome. What a very, very interesting answer, Karuna. And the other question you've got from this same person is, what are some things you should look out for before contributing to an open source project?
So I got to learn this the hard way, but I joined an organization which helped me get familiar with all of these. So I'm gonna share the advice which they gave. So whenever you see to contribute to an open source project, first thing you might see is the idea, if it fit into your tech stack, or you might want to learn the tech stack, but you like their idea and you want to contribute. So first things you will see is go to their project repo and see if the project is still active, because if sometimes the project is not active and you have made a pull request, all your efforts will be wasted. So I'll say just go to the issues tab or pull request tab and see if the project is still active. And again, just as I said, make your organization inclusive. So whenever you want to contribute to a project, see that their pull request, the closed pull requests, are closed with a reason. Let's say some pull request got just closed, and you might say all of the work which is good, and so some maintainer just closed it without explaining it. So that will discourage you a lot, and you might feel bad. Oh, my efforts are all in vain. Why did I contribute to this project? So that is another um, factor which you should consider before contributing. And other things are if you are finding good mentors, good maintainers, contributors, you can just go on and talk with them before contributing so that you will get the context behind the project, and do some homework before contributing, because mm, other maintainers and uh, all the people who are in the organization will appreciate that you did some homework before contributing to their open source project, and then you can go ahead and ask your questions. So that is my advice.
Awesome, awesome, Karuna. That was a very, very interesting one. Thanks for your time. We are so glad to having you in today's conference. And your presentation was awesome, absolutely awesome. And we are looking forward to seeing you doing more amazing stuff with the community, and also looking forward to seeing you present at the AsyncAPI conference next year. Thanks for having you. So one more
Thank
thing
you.
before I go, I would love to give a closing remark to Karuna's talk. So open source isn't an exclusive club, right? It is made by people it is made by people just like you. Open source is just a fancy term for treating the world's problem as fixable. So feel free to contribute to open source. Feel free to contribute to AsyncAPI. We are always and currently accepting contributors. Thank you. See you guys in 5 minutes. We're going on a short break. Thanks, Karuna. See you later. Hey guys, so sorry. We are going on a very, very short break. We have to go on a short break because the next presenter should be presenting now. And yeah, so so sorry. We are going on a very, very short break. So we are back again. And yeah, the next speaker in line with me is Nauman. So Nauman is a very, very interesting fellow, and I think he is also some of the people pushing, AsyncAPI forward with some amazing stuff they've been doing with the community and outside the community, right? So I'm gonna bring Naman up. So I'm checking if Naman is up. Naman, you up? Great. Hey, Naman,
Hi, how are you
how you
doing?
doing?
I'm good. How are you?
I'm doing fine. I'm so excited, to be hosting you today. And I'm pretty sure you have something interesting for all the people watching and every community members today.
Mhm. Yes, thank you so much for having me. I'm going to be talking about API governance today. I know it's a topic that's discussed a lot. I want to get into the practical details of how we can potentially achieve some bits of it.
Of course, I'm looking forward to learning more.
Awesome, perfect. So,
Okay, going backstage now.
hi everyone, I'm Nauman. So I'm a product manager at Stoplight, and I'm primarily looking at the API governance piece. API governance piece within Stoplight here. I know API governance is a term that's thrown around a lot, and it has a lot of different pieces to it. From how your workflow works within your API design, how reviews work, to actually managing and deploying APIs and eventually deprecating them. So there's a lot of different pieces to it. What I really want to get to today is actually automating some of those pieces, and primarily getting into API styles or style guides, and how you can potentially use them as an effective tool to make API governance better in your organization. So before I get started with how to get into actually creating these style guides and using them, I just want to set a bit of context into why we're talking about what we're talking about. And I took a quote from the State of API report that SmartWare does, and and what it says is standardization is the number one challenge that teams building APIs are looking to overcome this year. Now, when we talk about standardization, it's primarily, especially when you go on scale, let's say you're building hundreds or thousands of APIs, how do you make sure that people across different geographical regions and new developers or designers coming in make sure follow similar guidelines, and your APIs as an organization look similar, so that the developer experience is good for whoever's consuming it internally or externally. And API governance, like I talked about, has a lot of different pieces to it, but one general goal that we're looking to achieve with all the processes that we build around API design and development is consistency. You really want to be consistent in the APIs that you're building out. And while there are multiple ways to go about governance, some centralized teams, or pushing it more down to the teams that are building APIs, good API governance, in my perspective, is more about making the right thing to do, which might be following some principles or some specific guidelines or a workflow easy to do. And how you can make it easy is, I think that's the theme of my what I'm going to be talking about is automation. If you're automating the different pieces of your workflow, you're really making it easier for people whose main goal is to build APIs, make sure that they're doing it right. And from what we've seen from customers within the community, one effective tool to achieve that is setting up an API style guide. Be it if you're a small company just starting out, start with something small and define what good looks like in your organization. And especially if you're at scale, you'd want a style guide out there, much like you might have a style guide for how you develop apps or other things, just to make sure that everybody has a good sense of what best practices and what good looks like in your organization. There are a couple of different governance strategies. What we have seen over the years for large companies, like you'd see Google, PayPal, putting out these API guides, is a large PDF that might be a large PDF that might contain all those different best practices. The problem with that is that, one, it reduces the time to market, or reduces the time it takes for you to put APIs out, because there's a central team that has to look at all API designs and make sure that if that style guide is being followed, and feedback is always late in the process. Plus, another piece being people who need to follow these style guides, people who are building out APIs, need to read large PDF documents just to make sure what the style guide looks like. And now you cannot expect everybody to be doing that, and it's just cumbersome general. So the other piece, which has come and gained popularity of late, is automating some of these guidelines. Now you build out these API standards, and we'll talk about more about what these contain and how you can potentially make them part of your workflow. But the general idea being, if you can automate some of these rules, your reviews go faster because feedback is much faster, maybe within the design environment and within your review process. There's visibility across the board as to what those rules are, when those appear, and it scales well, especially in larger organizations. So the general idea being, automate what you can, and it's going to bring you a lot of advantages over time, especially as you scale your program. Just reiterating the point on how important automation is to API governance, and we've seen that across different people that we talked to. All right, so I talked about this a bit, but just to put into perspective, this is Google's style guide out there in terms of API design, and what it is a large website with different topics and how to go about versioning, what naming conventions to follow, what errors, how does Google do errors within the organization. This is great because at least there's an idea out there on what good looks like. But then again, for somebody coming in new or building these things out, they have to go and find the right topic that they need an answer for, and really make sure that they read through it before actually implementing it. Cumbersome, takes time. Now, what you can get to is the automated kind of style guides, which is on the left, what you see is a set of rules. These are built using Spectral, which supports both OpenAPI and AsyncAPI and other JSON things too, or other tools out there like OpenAPI, CLI from Redockly, where you can codify some of these rules and then run them in your CI, run them in your design environment, and get errors as part of it. So if you automate the guidelines itself, it really, like we talked about, really makes your life easier. So you could map what Google has as a PDF into some of these codified rules and run them in your, make it part of your process. Now I've talked about why you should be creating an automated style guide, but the question that is certainly hard to answer in terms of like the complete what should an API style guide include, what everything that it should include. But I'll try and give a sense of some of those things that you can include in an API style guide to make sure that you're achieving the right things. And in my perspective, I break it down into two different buckets. There are two different goals with these guidelines, especially with us as an industry, the API industry, or people building APIs, adopting OpenAPI and AsyncAPI as formats to design these APIs. One goal is to really churn out good API specification documents, be it OpenAPI or AsyncAPI, to make sure that the tooling that you're using, you might be using a code generator, or you might be using some other tooling that are documentation generated to power your workflow. So the quality of the API spec matters a lot, and this is one bucket of rules that you can create. An example being some async API best practices. First of all, you should have validation for your async API, so you're at least following the right syntax when you're writing these. But then you can go beyond that and say, all right, I want only this version within my organization. That might be the latest async API version. Using a particular protocol, adding valid examples, making sure the operation ID is unique, and adding information for like who the contactor is for this API and the license information itself. Just you can go through the async API document itself and say, okay, these fields are really important for tooling, for what we do within the organization with these specs. So you create rules for it. The async API team has done a really good job of actually creating the async API rule set they've been contributing to within Spectral. So you can go check it out, which has some of these rules already pre-built. So you can start with them and keep adding onto those to make sure that the async APIs that you're building are really good quality. Another bucket within this importance of building good async API documents is maybe you're using a gateway, right? So if you're using a gateway, there will be particular nuances of that, like the Amazon API gateway not supporting one-off within the JSON schema, or some X extensions that you might have for your code generation setup or your gateway setup. Again, you can codify these to make sure that everybody who's building out these APIs is adding these fields within the document, which really helps make sure that the tooling downstream works well. A big goal of building these documents is documentation itself. So make sure to add some documentation rules, like you should always have examples on payloads, add descriptions, what the length of the description should be, maybe add a grammar or a spelling check, just to make sure that the descriptions are not making you're not making typos within the descriptions itself. And if there are any other, if the tech writing team has any other requirements in terms of what good documentation looks like within your organization, you could add those into the rules itself and make sure that the documentation that you're producing is of high quality. This is one bucket, and I think it's really important to build out these rules to make sure that your documents are of high quality and the tooling works well. But then I think where it really gets interesting with these style guides and automating is building out some API design guidelines. And I would look at it as the first level as maturity level 1, where you're building out rules to make better API, open API, or async API documents, but then going ahead and saying, this is what good API design looks like within my organization. And one bucket of it might be API URLs. Now, every company wants to do it or does tend to do it differently. There's no one right way of doing what casing you should use or what your URL structure should look like. But decide on whatever you want to follow. If you want to follow some particular company, like say you really like how Stripe does it, take those conventions and build those rules out. Like what casing should my parameters be? What should I completely avoid within my URLs? And what the structure of my URL looks like. Now, if you have a good sense of rules on how your URLs are, anybody who's using your APIs would find it far more intuitive as to what the next call might look like. The next piece, which is always a tricky topic within organizations, is versioning. And while again there are multiple ways of doing versioning within organizations, it's good to at least decide whatever works well for you and codify it. So say if you want to go for path level versioning, or you want to do versioning within headers, whatever it is, make sure that everybody's doing it at the same way. Again, the goal being consistency itself. This is a big one in a bucket that contains a lot. Thus, I have all this. I won't go through all of it, but the general idea being make security a big part of your style guide. And what I've really found helpful is just to make sure that you're following OWASP's top 10, the rules there. You can create those rules and then go from there and say, this is the security scheme we use within the organization. HTTP basic, we stay away from it. We always add limits to our schemas in terms of if a string, what's the limit of it, if there are minimum and maximum properties and objects, just to make sure that some of these basic security concerns don't fall through the holes. They're easy, but they're still easy to miss too. If you have some rate limiting conventions, you should add that too. And this list can go on and on depending on what the security posture of your organization looks like. Error handling is another piece that you can add to your API style guide. Make sure you say in your style guide that you shouldn't be adding errors into successful responses, but also saying that this is what your error object looks like, and what the popular error responses that you want to have always within your API. All right, so these are just to summarize that a bit. There are two different buckets that you can build style guides out of. Go to API documents and then go to API design. Codify both of them and put them into one style guide that your organization, as a general, encourages people across the board to use and implement. But one piece is building these out, and it's certainly a big task to take up. But let's say you've gotten to the point where a style guide's ready. How do you roll it out? The first idea would be to socialize it within your organization using some sort of documentation. Considering this is This is a machine readable spec that you're building a style guide in. You can probably generate documentation for it and some markdown, put it somewhere where everybody can go find it and look at how style guides look within your organization. This is just one to get the idea of the style guide out there and to have conversations with people who are going to be actually using it, as to if this makes sense or not, especially in their use cases. Now, the next step would be to bring it where your designers or developers are. The idea being, instead of it being a document like we saw with Cool style guide, bring it to your design environment. So let's say you're using VS Code or some other tool to actually build these async API or open API files out. You can bring those errors into the design environment itself. So as people are writing these specs, they can get these errors and warnings within their environment. What this does is it gives real-time feedback, much like you'd have ESLint when you're writing code. It makes it easy for folks to follow the style guide itself. Like we talked about, governance is about making things easier, and this really puts it right where nobody needs to go and look at something to actually follow these rules. And you can divide them into some being errors, some being warnings, just in case of what do you think about this rule and the severity of it. And people can choose to ignore it. This is more encouraging people to use it rather than enforcing it. But then the next bit that you can do is make it part of your review process. So let's say you do your reviews on GitHub, you're following that workflow where somebody changes a spec, makes a pull request. You can run the style guide within the pull request itself. You get errors right there, and then have a conversation around why is this not fixed, or why is this error here, and if we need to ignore it, then have a conversation around it. But the general idea of anything that passes those checks and those conversations can be skipped as part of the review process, and you can focus more on rather more important things. And that's where I get to. Do you still need to review API designs? Yes. But the review can now focus on business capabilities, use cases. So what are you actually building rather than how you're building it, or what the casing looks like, or you're missing out in an error, or not using the right convention when it comes to API design. So more about does this API make sense? Does this solve the use case, rather than focusing on what the conventions might be. So your reviews are more useful, they're faster, and I think building API is much better and faster too with this. Now, a style guide is a really effective tool, and I think one that has good tooling around there to actually start doing this. But beyond that, what else can you do? And these could be separate conversations in terms of governance. But having an improved diff system so that people can look at what has changed as part of the review process in a better way, and some sort of breaking change detection, just so that you're not putting out breaking changes without knowing about them. So make this part of the review process as to a better diff, hopefully not JSON or YAML, and some sort of a breaking change detection. And there are open source tools out there that do that. And then going from there, you can build out a concept of a reusable API components library, which might have models, parameters, headers, error responses that everybody should use, just so that people can get started with it quickly and keep reusing stuff rather than building it out, so that there are 5 different types of errors that your organization's APIs throw. And templates being another, I think, next step. Once you have a style guide, a good sense on what good looks like, you have reusable components, you can put out templates and say async API documents and open API documents saying, if you're building this kind of an API, use this template, get started with it, just to make the process even faster than what it would be without these. Thank you so much. This is what I wanted to talk about. Hopefully it was useful. If you all have any questions, let me know.
Thanks, Nauman. Okay. So we had an amazing. Uh, what's going on? So we've had you just like enlightened me so much. I learned so much about how to automate API governance in your talk. Yes, I think a couple of folks are actually like inspired by your talk. In short, you have two questions, right? So the first question is from Wukash, and he says, "Are big companies still doing manual governance approach?"
Mhm. Um, I'm hoping more and more are moving towards the automation bit, but yes, I think there has been more of a push towards automating some of these processes. The concept of legacy APIs, the overhead of building some of these style guides and automating them, and just generally, I think more knowledge around what you can do with these tools out there is helping, but we as a community can certainly do a lot more. But I certainly in the past year or two, I've seen a lot more big companies put out their own style guides that are automated and are really putting it out there. I think one thing that I'd stress on, if people who have built out style guides, we should put these style guides out there for public, just so that other people can get ideas from, and we as an industry can grow on what good looks like when it comes to API design.
Okay, awesome, awesome. I love that. No one, I love that. So the question is actually from a folk called Ilibidi Aziz. So it said, apart from automation, what are some drivers we should be focusing on to quickly mature our governance approach?
Mhm. Yeah, so and like I said, I think there's a lot of different pieces to governance. Putting out a style guide and some of those pieces of automation that I talked about help. But one big piece I think that really does help organizations is visibility. So make sure if you're using the spec itself, create a catalog of all your APIs so you know what APIs exist. When you know what exists, you can actually find problems and find solutions to how you can potentially improve your maturity. And to general, I think sometimes assuming that every across the board there's knowledge around these tools like OpenAPI, AsyncAPI, what tools out there. That assumption can be wrong at times, and just general um, sharing knowledge across what is coming up and what these tools can do across your organization really helps.
Interesting, interesting. Thanks for clearing that up now, Norman. And so, if you have any question for Norman, you can easily reach out to Norman. And I'm pretty sure if you want to learn more about API governance, and I bet Norman is a go-to guy. And yeah, so would you like to can folks reach out to you on Twitter or on Slack? What's the Slack channel at the AsyncAPI platform?
Oh yes, I'm on the Async API Slack, so you can always reach out there, and on Twitter and LinkedIn too. So anyway, I'm happy to answer any questions or have discussions around API governance or design in general.
Awesome. So I bet you would eventually see me in your inbox also because I would love to learn more about API governance.
Perfect. I'm looking forward to that.
All right. Well, we are so glad to having you, present today, Nauman, and also we are looking forward to seeing you doing more stuff with the community and helping push Async API forward, and also with all the cool stuff you are doing. So we are so excited to have you, and we are also looking forward, to having you next year at the Async API conference 2023.
Thank you. Bye.
So, all right. Thank you. See you next time, Nauman.
See you.
Yeah, so an amazing presentation from Nauman. So you can reach out to Nauman on Slack, on Twitter, if you have any question about API governance or you would love to learn more about the presentation he just gave. So that's everything on Nauman's presentation. And now we'll be going on a short break and we'll be seeing you guys at 1:20. Seeing you guys later. Bye. Hey guys, so I hope you guys have enjoyed your break, and yeah, so today, now we have the next presenter, which is our own very David, and yeah, so let's just get right into it. David, are you ready to come online? Awesome, coming up stage now.
Cool. Hello. Can you hear me okay?
Hi, David, how you doing?
Yeah, great. How are you?
Yeah, I'm doing fine. I'm so glad to be the one hosting you, man.
It's wicked. It's good to be here. That was awesome.
Yeah,
Yeah.
awesome. So glad to have you back today.
Yeah, no, it's great. Yeah, I'm looking forward to doing the talk and see what people think. For sure.
Yeah, so for most folks,
Well?
yeah, so for most folks who don't know David, so David, I would say David is a rock star at AsyncAPI. So he has done some amazing projects that has helped push the AsyncAPI initiative forward. And yeah, so that's why I'm so excited to have David today. Before we get started, David, do you have anything to share?
Not really. Just hope you all kind of enjoyed the talk, and thanks so much for having me here at the conference. Any questions you have, I'm kind of on the channel as we go. I'm happy to answer any questions afterwards or anything. So yeah, I hope you like it.
Awesome, man. Yeah, so let's get right into it.
Hello everyone at AsyncAPI Conference. My name is Dave Boyne, and thank you for having me today and kind of watching this for the next half an hour. What I'm going to be talking about is cataloging your events with AsyncAPI. And what do I mean by cataloging and documentation? And that's exactly what we're going to be diving into today. So here's a quick agenda for you. What we'll be diving into some initial problems actually that you'll see and what I see the community kind of talk about and problems that I've had in the past with that initial setup of event-driven architectures and the problems you start to see and emerge as time goes on. So before we dive in, I'm going to introduce you to myself. My name is Dave Boyne. You can find me on Twitter at Boyne123. I'm a senior developer advocate at AWS. Focused on serverless technologies and also event-driven architectures. I'm a father of two, so you might hear them scream in this video. They are in the house, and so listen out for that. Ex-guitar player, and previously before at AWS, I was working in open source full-time, actually part of the AsyncAPI team for a while, and before that working in startups and some large organizations, mainly focused around tooling, developer experiences, and all sorts of things. I also enjoy kind of writing open source software and tools for developers and focusing on event-driven architectures. So let's dive into this talk and talk about the problems of event-driven architectures beyond that initial setup and things that you might see, and maybe some of these things might resonate with you. And as you look around in the community at the moment, you can see actually the adoption of event-driven architecture is growing, right? More and more people are using it, more and more solutions are being developed with a kind of this event architecture in mind. And when you start diving into the reasons why, it's because I believe technology is just making it more accessible, right? Event-driven architecture has actually been around for decades. So it's about the technology and how that's helping us do that. And if we just have a look at some AWS services as an example here, we have things like Amazon EventBridge, which is a serverless event bus, which allows us to send and receive events and map them up to other serverless kind of technologies there. We have kind of step functions that allow us to orchestrate some workflow based on events, and even things like Lambda, right, which allow us to kind of do some compute based on events, funny enough. So the event architectures themselves are actually becoming more and more accessible. And then when we start looking at the benefits of event architectures, you start seeing these kind of words come up. We aim to have loosely coupled systems, especially in this kind of microservices architecture, especially as we have different teams doing different stuff. Event architectures allow us to kind of produce these events and consume them in different teams and process them in different ways, right? And having this loosely coupled system allows us to have this extensibility, which allows us to have consumers come and go as time goes on. So as requirements change in our organization, we can change who's listening or add more listeners and do more and more things. And event architectures just really help us from my own experience, just help us get there. And then when you start getting into that kind of flow, you start seeing this agility arise, which is, we need to do X when Y happens. Well, if we are already publishing Y, then we can just do the X anyway, because there's no work that needs to be done there. And as you add events and you start designing your architecture in this particular way, you start to see this kind of agility that emerges. Now, what tends to happen is once you go beyond that initial setup of your event architectures, you start to see some weird kind of problems emerge, right? And normally it's not around the technology, but more around kind of behaviorals and people in general, really, to be honest. You start to kind of question, the producer and consumer responsibilities as an example. So who owns the contract here? Right, or maybe it's validation. Do you validate at the producer level or the consumer level or both? And then in the middle here, we have coupling services with events. So even the event design itself can actually couple you to your producers without you even knowing. Lack of governance and standards as time goes on. Should you be thinking about your event design and the impacts that actually has on your organization? Even to the point of the event naming itself, the unclear event intent. What is the name of our events? Are they past tense? Are they things that have happened? Is it clear what we're looking at? Exposed domain information. Are you exposing too much integration or internal information within a particular kind of bounded context or a particular service? Should you be exposing? What kind of domain information should you expose, and where's the line there? Finally, things like, focusing on implementation details rather than behavior of your system, looking at the events and things like event storming there can help. Now, when you start diving into event architectures and you start reading books or white papers or whatever it might be, you start seeing this term arise, which is producers should not know about consumers. And although that's kind of true technically, we want to create this decoupled architectures, what I believe happens, is we take this too literally. And what happens over time is you start to ask yourself, who is producing what? Especially if we have hundreds and hundreds of events and we've scaled this out in our organization, you want to know some basic stuff. Who is producing what event? What version of the event are they producing? Who can I contact? Who owns this event? What information and context around this event? Why was this event created? It could have been created 2 years ago, as an example. So as you start to look and come into these issues, you start to look and wonder, is there any kind of event-driven documentation that can help us solve these initial issues and these problems that we have? Now, luckily for us, this is why we're all here at the conference, is that we have the AsyncAPI specification, which is great. It allows us to kind of document the producers and consumers using various different kind of protocols and document our channels and be able to have a place where we can actually say, okay, here is my service and this is what you can do to it as a producer or a consumer. This is the kind of stuff that this kind of stuff is doing. Now, the best thing about the kind of specifications and standards in general is we can actually create tools around the specification to help us get to that next level of documentation or that next level of like CLI tools or whatever it might be. And that's what I'm going to talk about next, is introducing event catalog. And what is event catalog? Now, to explain this, what I want to do is actually want to just focus your attention on these 3 different areas that I've been kind of exploring for the past few years. And these kind of are the things that kind of get me excited personally, which is event architectures, developer tools, and developer experience. Now, over the past few years, I've been diving into event architectures, reading books, experimenting, playing, and developing tools and all sorts of stuff. And I come across this book in particular, recommended to me actually, by James Urquhart, which is called Flow Architectures. Now, James looks into kind of the future of event streaming and event-driven integrations within our organizations. And if you think about this for a minute, you think about data and cross-boundary data within your organization, we are always integrating with third-party providers. Especially kind of startups, we're looking at different SaaS providers and things we can integrate with there, or data lakes and all sorts of things. So to how we do that today, we mainly focus on like webhook integrations or whatever it might be. But there is becoming more of a need to have this data kind of real time. And as James kind of explores in this book, which really resonates with me, is like the future of these streaming platforms and the future of events and data sharing, and how do you get access? What happens if I can just subscribe to a stream of data rather than setting up all this stuff all the time, this integration and testing and the things that we have to do. But anyway, a part in particular in this book that really stood out to me was this Wardley map. And as you can see here, I've highlighted on the left, is this discovery phase, discovery of producer and consumer and the need for that and where that is along this whole life cycle. And because it's on the left, it's kind of indicating that this discovery phase still kind of needs more work and it's not really ready for us to kind of move along in that sense. So it kind of just got me really thinking about how can we look at tools or ways in which we can, with event-driven architectures in mind, allow us to discover events and document events and producers and consumers easier. And that's the key really here, is easier, and having that developer experience in mind. Now, as I was continuing to dive deep into event-driven architectures and standards and various things like that, I come across Fran Mendez on Twitter, right? And he was like, so I was building a tool, and he was like, hey, would be cool if you could integrate with AsyncAPI. And I was like, what's AsyncAPI? And I come across, the AsyncAPI specification, which is great. It literally solves a lot of the problems and things that I've been thinking about and things that I will kind of want to use and want to explore more. The ability to document the producers and consumers, the ability to go somewhere and see exactly what this application is doing from an event-driven point of view. And as I mentioned, the great thing about the specification, it allows us to write tools and kind of see what else is possible. So I started to look at some tools and build some open source documentation tools that kind of really resonated with the community and people online, that allows you to take like schemas or schema registries, for example, with EventBridge, and generate some documentation for you, some static content where you can go and host these things and kind of read and kind of document your schemas to the next level. And I also integrated this with AsyncAPI, which takes your file and transforms it into some kind of 101 documentation and static website as an experiment. And as I started exploring this, more and more people kind of found it useful, which I found very interesting, which kind of mapped to that whole discovery phase of event-driven architectures and that need to have something there to help these organizations scale their event-driven architectures in general, really. And as I focus on these tools and focus on kind of open source tools in general, I spend a lot of time diving into what does a successful open source tool look like. And it's kind of a lot of emphasis goes around documentation of the tool itself, but also the developer experience that you have. And when I start thinking about how people make websites and that experience with Markdown files and also MDX files, which allow us to have components within Markdown files to allow us to custom render things on the screen, I started thinking about, can we use Markdown and MDX files to actually generate event-driven documentation and also include the AsyncAPI specification in that to help this whole discovery and documentation phase that I've been thinking about. So I started thinking about how can I kind of line the three up, which is event-driven architectures, line it with developer tools and standards and specifications like AsyncAPI, and also try and create this developer experience where people already know how to kind of use the tool because they might be familiar with Markdown, for example. I really wanted to try and give something back to the community which allows organizations and people to really document these producers and consumers with visualizations and components and all sorts of things. And that's when I decided to kind of build an experiment with this tool called Event Catalog. Now, what is Event Catalog? It's an open source project that helps you document your event services and now domains. It can actually take your AsyncAPI file or files that you have and actually generate it into a static website. right? And you can also, the static website will also host mermaid diagrams and schemas and all sorts of things, and 3D node graphs, and integrates with AsyncAPI as a plugin. So here's an example page of an event that on event catalog and what it might look like. And you can see everything here you can customize. So your producers and consumers on the top right, here is the event called item removed from cart as an example. It's a version 1.5.5 event, and its producers is the shopping API. And we have a consumer, which is the customer portal. And this is all documented using Markdown. And also, you can also all document this using AsyncAPI files. And what the plugin will do is it will take that and generate this for you. You can download schemas, and you can also see the schemas or see custom MDX components, which is like mermaid diagrams, AsyncAPI file renderers, and all sorts of things there. So here is the AsyncAPI plugin. This is how it works. So when you initiate an event catalog, you install the plugin and you put the path to your AsyncAPI file. And then when you run generate, what it will do is it will parse the file and generate your events, your producers, and your consumers. So what I'm going to do now is actually take you through a demo. What we will do is create a new catalog. We'll add an AsyncAPI file, install the plugin, and we'll generate our catalog from our AsyncAPI file, and then look into what else we can kind of do there. So let's have a look now and see that in action. So what we're going to do now we're in the terminal is actually create our new event catalog, and we do that by running npx @event catalog, create event catalog at latest, or without the latest command if you want, and then we're going to call it my catalog async API. And what I do that is when I press return, that will kind of set up the initial foundations of our event catalog. What I'll do for this video is kind of fast forward it, so it'll take a minute or two to do that, and then I'll show you how what it looks like initially and how we can use an AsyncAPI file with the plugin that we use. Cool, so now what we're going to do once that's done is we're going to go into our AsyncAPI event catalog, and then we're going to run npm run dev to just start it up and see what it initially looks like out of the box. So let's head over to the browser. Great, so we're now in the browser and you can see we're on port 3000 and our application is now running. And out of the box we get some standard stuff. We get events, services, domains, and visualizer. And if we click on them, we can see, if we go into the events, we can start to see all the types of events that we kind of get out of the box. We can use the filter here to start looking for events if we want to, and also filter by events by different services. We can also dive into services themselves and be like, okay, what is this service doing? So if we click on the basket service, for example, we can see the basket service itself is actually publishing these 3 different events. As we come down here, we're using MDX components to visualize the basket service and the corresponding events that it's raising. And also we can provide some metadata inside of this page, which is like the repository link, who owns the event, and maybe we can view it in the visualizer. If we head over to view in the visualizer, this will load the visualizer of our whole event catalog. And we can start going down here and exploring our events and our domains. For example, the basket service publishes this file, publishes this event, which is subscribed by the data lake. We can just start using markdown files to generate visualizations and documentations into event catalog, which is an awesome way to kind of just render some static content around your event-driven applications. So let's take a look at the code and just see exactly what it is that we get out of the box before we implement AsyncAPI. Cool, so now we're over in the code, and what happens outside the box, what you get is you get a domains folder, events folder, and a services folder. And all that's inside of there is markdown files. So as you can see, we've got our events, and we have an order complete event, and we have a markdown file here. And this markdown file, we have some metadata, and everything is documented online in documentation. But you can say, okay, the name is order complete, we have a version, we can put a summary there, our producers are these, our consumers is this service, and we also have some owners. And then we can use some custom MDX components that the community has built on top of event catalog to be able to kind of render different things inside of our event catalog itself. Now what I'm going to do is we're going to actually delete these, and I'm going to install the AsyncAPI plugin, and we're going to use an AsyncAPI file to generate this document, this catalog ourselves. So step one, what we'll do here quickly is just delete domains, delete our events, and delete our services. And then what I'm going to do is head back over to the terminal, and we're going to install the AsyncAPI plugin. Okay, so now we're here. What I'm going to do is just install the plugin for AsyncAPI, and we do that by doing npm install event catalog plugin generator AsyncAPI. Let's go back to the code and set up the AsyncAPI plugin. And the way we do that is we go to the event catalog config file, and now we have to actually install and use the generator. And the way we do that is we include the generators, the generator part of the file, which is this. So generators, and we point to the AsyncAPI generator, and we need to pass it the path to our specification. So let's put the AsyncAPI file directly into the root of the project here. So what we're going to do now is create a new AsyncAPI file inside the root of our project, and I'm going to copy an example AsyncAPI file into here. So this is using the Streetlights Kafka API that you can find on the AsyncAPI project and examples repo. And we're going to use this to generate our event catalog. So what I'm going to do now is go back to the terminal, and now what we're going to run is npm run generate. And what this will do is it'll take the AsyncAPI file and parse all the events and the services and turn them into event catalog information. So let's now run the catalog and see what it looks like in the browser. So now let's head over to the events folder, and we can see here that we have dim light, light measured, and turn off light, which is all version 1, which is our AsyncAPI version. If we click on dim light, we get shown the event itself, a command in particular streetlight to dim the lights. And if we scroll down, we can see the schema, and we can see this nice diagram here. We can also use event catalog to actually download the schemas themselves. So if we click on that, it will allow us to download it locally to our machines. We can also see the producers here. So we see the Streetlights Kafka API as the producer of this particular event. So if we go inside there, now we're in the services folder, we can now see the Streetlights Kafka API, which is all documented for us. Again, everything you see here is from the AsyncAPI file. We can see that the API itself consumes this light measured event, but also kind of produces this dim light and turn off event. We can navigate to the events and the producers over here in the messages. We can also use the visualizer to kind of scroll through the all the events and kind of visualize our whole landscape using this all events and services feature up here. We can drag our nodes and kind of start visualizing and seeing what is going on using this particular tool. And if we're interested in a particular service, we can come down here and click on that and see that itself. We can also start using the 3D node graph as a way to kind of visualize events going to and from this particular service. Now, this is great, but what happens if we make changes to our AsyncAPI file over time? What happens to event catalog? Well, let's make some changes to event catalog first, and then we'll make some changes to AsyncAPI, and we'll see how the two work hand in hand. Let's go back over to the code. And what we'll do now is we'll make a change to this dim light markdown file. So maybe we want to add some more context here. This is where event catalog can kind of really help you document your event-driven architectures alongside AsyncAPI. For example, because this is markdown, we could add any information we want here. We could just have hello world from my dim light. If you are going to use this, make sure you follow the instructions found in the project README, whatever else it might be. We can save that, and when we go back to the UI, we'll see that rendered. So let's have a quick look now. As we navigate to dim light, we can see here is our changes there. So let's make some changes to our AsyncAPI file and see what happens. So let's head over back to the code. In our AsyncAPI file, let's update the version to version 1.1.0. And let's say we want to change dim light to have some different kind of summary. Command to book a particular streetlight, let's just say. Let's have a look at the dim light payload, and let's change some stuff here. Let's say the maximum is no longer 0 to 100, but for whatever reason it's a 0 to 1000. We save the changes here, we've updated the version, and what we're going to do now is run generate again to generate our new events. And what event catalog will do with the configuration that we set, it will actually understand that the versions have changed and it will version the events for us. So let's go ahead and run this command, and then I'll go back to the browser to show you exactly what has happened. So what I've done here, I've run the generate command again, which I didn't show you because it's just a console. But what's happened here is actually we've gone back to our event and it's actually upped it to version 110. Now the README file hasn't changed, it still stores our information, everything below this line is stored, but we regenerate this top bit using the metadata of your event. And also what you can do here is you can also go back and see previous versions of your AsyncAPI file. So an example here would be dim light version 1.00. If I click on that, we can actually see the old event, the old information, and we actually get a warning that we're currently looking at an old version here. And the great thing about this, we can actually diff the changes and view the changes using event catalog. So you can see here schema version is updated from 1 to 110 latest. And even better, what we can do is we can add a change log to this version itself. So let's just go to the code quickly to add a change log. So example of adding a change log, what we do is we go to dim light, we see this new version folder, and then we can see 100. And if we come in here and we add a change log, and we can add any information we want here, again it's just markdown files, so we can say why this particular change was made. We save that, we go back to the UI, and as you can see the changelog is now rendered. And this is another way to give developers and give people in your organization kind of just information about why your events are changing using your AsyncAPI file. So another great addition there to just help you discover and understand what is going on. So the final thing I want to show you is an recent addition to the event catalog, which is using AsyncAPI without the plugin. So what you might do there is you might define a service and actually use the AsyncAPI MDX file to generate the AsyncAPI documentation. Let me just show you a quick example of how you might do that. So if we go back to the code, what we're going to do is create a new service. Let's create a new service called My Service. And what we're going to do is we're going to create a new index file. We're going to copy what we had here and put that there. We're going to change the name to My Service. And let's just change the summary at the minute just to be My Demo Service. Okay? And what we're going to do here is we're actually going to not render a node graph, but we're actually going to render async API component. Now what I'm going to do is put the copy this async API file and put it inside this service. Now what this component will do is it'll render out the async API file that's directly against this service. So if you have multiple services and multiple async API files, you can start using event catalog to render these things side by side. So if I save that, I'll show you exactly what I mean when we go back to the browser. So now if we click on services at the top, we'll see My Service, the one we just created. And if we click on this, it will show us that our new service, My Demo Service, what we just defined, and what it will do is render this async API file for us using the async API tools from the community. So you can come down here and you can see, okay, here are the servers, here are the different times of operations, look at the parameters and everything else like that. You can combine this with event catalog components if you want to render more documentation or render graphs or visualizers or metadata or owners or services, whatever you want to do. You can use event catalog with or without that plugin to kind of render these different services. So that's a quick demo of how you can use async API files and event catalog to generate static content that you can host anywhere for your development teams. You can use event catalog to document events, services, and domains. Use your async API files to help generate that. So hopefully you find it useful, and if you want to get started, head over to eventcatalog.dev. And what we're going to do now is just quickly summarize what we spoke about in this talk and extra resources to help you get started. So as I said earlier, the adoption of event-driven architecture is growing. We can see that in the community. We can see that with the technology and what it's allowing us to do with kind of less really within our organizations. And again, you can kind of see this definitely in the AWS community and the serverless community using event architectures to kind of boost their organizations here. When we look at event architectures in general, you kind of see these kind of themes that emerge that is allowing us to do, to have loosely coupled systems, extend our systems with this whole producer-consumer relationship, and that itself provides agility to our organizations. But the problem is, as I said earlier, that when you go beyond that initial setup of event-driven architecture, problems really start to emerge. And more, often than not, it's not really technical problems, although there are some, don't get me wrong. It's more kind of behavioral problems or design problems or architectural kind of problems. And don't worry, the great thing is AsyncAPI is actually here to help. There's a great community behind it and great kind of passion and drive that comes from this project. So I really recommend kind of scanning this QR code if you haven't already. I mean, I guess you're at the AsyncAPI conference if you're watching this, but really dive in and check it out and check out the tools that the community have built there, which is awesome. If you're interested in documenting or a documentation tool for event-driven architectures, I'd love to get your feedback on Event Catalog. If you're using AsyncAPI and Event Catalog, or if you've got any more information or anything like that, just check out eventcatalog.dev and have a play with it. Check out the static content that's already hosted on the website as a demo. Hopefully it can help you in your organizations. If you want to kind of join the communities, come and say hello, or got any feedback or ideas, just get involved. On the left here, we have AsyncAPI Slack channel. So again, scan that code there and sign up. And then on the right, we have Event Catalog Discord channel. So if you've got any ideas for plugins or any ideas or features or problems, we have a small community there kind of really helping each other, which is awesome to see. And kind of just exploring Event Catalog and just seeing how it can actually help your organizations kind of cross this boundary of this EDA kind of documentation and discovery kind of problems that we have. And thank you so much for listening. If you kind of made it this far and got to the end, my name is Dave Boyne. Again, you can find me on Twitter, Boyne123. And I just want to thank you all for listening to this talk, and also thank you all kind of for inviting me to the AsyncAPI conference to give this short talk to you all. So, and I hope you enjoy the rest of the sessions, and thank you very much for listening.
Hi, Dave. Are you ready to come offline?
Hello.
I just learned so much in your presentation, and it was an amazing talk. I'm so excited about what Event Catalog can do, and also the future of Event Catalog, and how it is also helping I think KPI get more recognition in the event-driven ecosystem, right? So, do you have anything to share?
Not really, no. Event Catalog, everything's open source. Obviously, like the Async API spec. I feel like with all this stuff, we're kind of just riding out. We're just at the beginning, right? So I think there's loads of stuff to explore, loads of things to do. And if you're interested in joining, either of these communities or both these communities or helping out, just feel free. Feel free to reach out if you've got any ideas or problems, or if you're kind of interested in any kind of event-driven solutions, just come join us and figure out how we can make this world better, right? And just come together. It's brilliant. Feel free to reach out to me whenever you want.
Great, David. As you can see, folks like David and the rest of the community are actually the people shaping the future of event-driven APIs. And so I can't wait to see much more things get done by you, David, and the whole communities behind Event Catalog, and also the whole communities behind the Sync API. Thanks for coming, David. We're looking forward to also seeing you in the next conference, 2023. So excited.
Yeah, thank you very much. Yeah, thanks for having me. It's been great.
Yep. All right.
All right.
So the next speaker will be coming after a quick short break. And the next speaker will be talking about contract-driven development in async API tools and procedures. So looking forward to that presentation. So I'm seeing you guys at 13:20. Sorry, I think 14 o'clock. Okay, so seeing you guys later.
Hey everyone, and welcome back. Hope you guys are having a great day. And our next speaker is José, who will be giving us the next session called Contact Driven Development in Async API. José, are you ready to come on stage? You can just wave your hand. Okay, cool. Let me bring you up.
Hello, how about you?
How are you doing?
So far so good. And yourself?
I'm perfect, thank you. Would you like to say anything before we play a session?
As I'm very grateful to be here with you talking about content app development, and it's absolutely an honor just to share this knowledge with you guys. Hopefully, people like it.
I'm grateful that you're here today and you're joining us today, and I'm sure the audience will learn so much from you today.
Hopefully,
Yes. So without any further ado, let's tune in.
hello world. Thank you for hosting us here in this amazing conference. We're going to talk about content-driven development in Async API, tools and procedures, something that we use in our day-to-day in order to create our amazing software. But first of all, let me introduce myself. Who I am? My name is José Enrique García Maciñeiras. I am principal software engineer here at Sngular, coordinated by Sngular for the moment, with more than 16 years in this mess, fighting in different places and in different trenches. Nowadays, I am the leader of the open source initiative, the OSS, also the Special Service Office here in Sngular. I am the father of Calogene, the multi-API generator and the multi-API contract converter. These three projects are one of the main ones that we deliver to the community, so we can share with you our amazing coding styles and our good to do the things. Okay. I also are the master slave for my two cats, Kiko and Kitiara. What can you expect from this conference? Just another way to do the same, another tool to do the same thing you are doing every day, another way of thinking, another path to try maybe, another thing to discover, or not maybe? So first of all, let me tell you a story. When I was a younger kid, I was a fat, hairy young fella. And as usual, the people started call me names. I was called gorilla, monkey, chin, blah, 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 blah. So you have two choices regarding to this point. Fight them or embrace them. The first thing I do was fighting them. So was amassing fights, kicking and kicking. But at the end, I embrace the gorilla thing. So let me introduce one of my friends. Once upon a time, there was a mono called Lito. Monolitho was in charge of his pack. So he feed the pack, he defend the pack from others, he communicated with all other packs, and he was doing all monkey mono stuff. The time passed. Litho was a successful mono. His pack grew more and more, with more females, more monkeys, more chimps. He was a really nice and big pack. Other packs looking as a successful mono, so they wanted to make business with him. He was busy and he was happy. The business expanded. Everyone wanted to work with Monolito, requesting food, requesting protection, requesting all monkeys, different apes stuff. And different apes start contacting to him to work together. So he faced the problems. There are different names for banana, there are different names for tree, there are different names for whatever thing the apes do every day. Other types of food were requested, not only bananas, just only nuts or different fruits, and more stuff they were requested. So, what he made? Litho has a problem, but Litho was a smart gorilla. So he started thinking and thinking and thinking, and he got a big idea. He defined a way to talk to each other, so he can communicate with different apes, with different monkeys. He structured a message system in order to communicate the data or the message between all of them. Something that was easy to read and easy to understand to all the apes. Mono sketched what he called the apes petitioning interface, or the API, defined it as an structured way to request bananas and other stuff from me and my pack. Monolitho was happy. Every ape in the jungle was starting to use his API in order to request information and send information. In apes from other jungles started to communicate with them, so he expanded his business to other jungles. He sent his small apes there so he can start working in a huge corporation. You are really happy and really rich for now. Monolitho age, and he needed more hands to help me. So he started to delegate all his knowledge and expertise in different small apes, like a micro apes that start working in different jungles. What can go wrong? They have the API here, so he can exchange information, exchange data, may request it. Happened that other species appeared on the stage, and he wanted to talk with him and cooperate and increase the business and share information between each other. So he needed to improve the API. He needed to control the transactions to avoid the API to be tweaked and broken, so the information keep stable between all the transactions. So Mono created a way to control transactions, or contracts, defined it as framework to guarantee the correctness of the message exchange through the API. Monolitho and their colleagues were happy, really, really happy, because they found a way that keep the API stable, that the information we share between all the different apes and different groups and different packs doesn't matter which was the language, they will understand each other. Okay, let's gonna talk about contract testing. What's meaning contract testing? What is contract testing? There are different definitions based on where you make these testings. You can make the testing for the consumer part, you can make the testing for the producer part. There are different approaches about that. Contract-driven development try to join both approaches in one. So taking the common points, that is, you have two actors, consumer and producer, is based on schemas, so you need to define what's the structure of the data that you are sharing between the different actors. There are some kind of field bindings, so you have defined your field with some limitation, with some constraints. Let's say a part of the type is string, integer, float, decimal. You can specify some regex, you can specify some limits, top limit or lower limit. And the main important thing is this is an agreement of minimum. So what you are guaranteed is that you at least will send the specific data, defined data that is in the contract. You can send more of that, there is no problem, but you cannot send less than what is specific in the contract. Excuse me. Right now there are two big pledges in this world. Pact, with the Pact broker, and Spring Cloud Contracts, that is an open source solution from Spring. Pact is a pay solution, so you pay for to have your broker and you use the system. Spring Cloud Contracts is open source, so you need to install it and do it by yourself. This one is my favorite one. So we are going to talk about it. So, as I said before, contract testing guarantees the correctness of the message, meaning that I am maybe a bit hard on it, that you guarantee that the message is sent and received as has been defined in the API. So you will receive the fields with this type, and you will add some kind of validation for that. Let's say that you are sending a string, you will not send a number. So the tests that are generated are verifying that it is going to happen. It allows us to test both actors. So you will have validation for producer and test for the producer part, generate the stats for the testing, and also validate the consumer part. So it tests almost every part of this exchange. One strong point of the contract-driven development is that they give you independence between the teams to develop. So once you have defined your API, you generate the contract. These contracts are shared between all the teams. So producer teams, provider teams will have a mock request that will request the data, and it will validate the response. In this case, you will receive a specific event, and we validate the event that is produced by the provider. Regarding the consumer, it will receive event produced for a mock. So what does that mean? That my consumer will be listening to a queue or a channel and will receive a data that more or less is defining this contract, so it can test his own business logic. So that's the main point of and the strong point of the contract. Once it's defined and shared between the teams, they can start working independent without no problem, meaning that when they reach production, maybe it's not 100% guarantee, but let's say 90-95%, all the communication will work quite well. Contracts are integrated in the build part of the project, so in theory, because you know that something can happen always, all the code will be validated in the build stage, so nothing will reach to production if all the things are done properly. Okay. So what is a contract? Well, we have here a sample about a contract, how a contract is. As you can see, there are two different sections: the input section and the output section. The input is made for the provider to receive the message or the consumer that is receiving the message, and the output is made for the producer. So the producer will send the message to that channel defined in the send to part, and the body will have those fields. You can see here that there is some data. This data will be used to create the stubs for the consumer. So the consumer will receive a message with name Adama, the account number 0002, and the update date 2022-10-21 at 4:30 p.m. in the morning. What happened with the input part? The input part will mean that the provider will receive a message in this channel, and this message will have that body, an amount of 2.5136, blah, blah, blah. The last update is a character. I don't care about that because there is no boundary about that. The name will be Adama, IDs, account number. All this data is created or defined based on what is specified in the contract. So as you can see, this kind is made in YAML language, so it's kind of readable. We can also define it in Groovy, that is more or less as well as readable, or in Java. Okay, this is maybe not a readable language, but it's not so complicated, right? About how we can trigger those tests. There are three different ways so I can trigger a test into a contract testing environment. So I can have a trigger function. I will see later the examples in the real code, okay? So I can define a function that will produce an output message. So the contract framework will receive this message and will validate it. We can produce a message based on an input. So the system will receive an input, define it in the app part of this example. The business logic will do all the magic and will produce an output message that should match the one that is specified in the output message. Or I can receive an input message without no output. Let's see that we are creating a service that is a sync, so we only receive message. So we only have the input part, meaning that this message will be received by the system, and I should provide a function in order to make the validation. Okay? So in a Spring Cloud contract, there is no attachment to a specific product, meaning that I can keep the contracts wherever you want. If we're talking about the path system, you need to have the contract in the path broker, so you pay for it. But in a Spring Cloud, you have it in your Git, you can have it in the file system, you can have it in your local folder or whatever, so there is nothing that you need to pay for. You should provide it, okay, but I mean, it's free, okay, happy news. And also it's a polyglot, support different language. So I can have a team in the backend working in Java, and I can have a team for the frontend working in Node.js for whatever reason I have. So the tests will be defined and created for both people. They can have another team working in Python that will be also receiving their own testing. So it's open to whatever language, right? But okay, this conference is about AsyncAPI and contract, how these two concepts, how these two worlds can match. Well, AsyncAPI is, as an API petition interface, will define how the communication will take between different apes. Contract will provide the necessary tools to ensure the communication is done effectively. So how it can be done, how I can use the power of those tools, of those specifications, for guarantee that my messages are provided and are working and the system is perfect. Well, let's go into this another thing, the API first paradigm, meaning that you should define first the API, then we should create the contract, and then we start working on building our solutions. That can be a bit controversial, right? Because we will have a working API defined by the ape petition interface. We will have a framework for testing the service, but we should keep updated different set of files. Ones that will define the API and ones for define the contract. Remember, I said you define the contract in YAML, in Ruby, or in Java files. But the AsyncAPI is made in JSON or in YAML. So it's different, it's more work for the teams in order to handle this. So is there any solutions? It's complicated, we face that. Having the AsyncAPI files in one repository and then the context in another repository. We were updating the AsyncAPI and someone forgot to update the contract, so the tests start failing, the product start not be deploying, so it's like a really headache. So we found a solution. We create the multi-API tools. Woohoo! Fantastic. So what we have here? We create a Spring Cloud Stream multi-API plugin in Maven and in Gradle that generates code based on the AsyncAPI, so we can generate our own code, Java code for the moment, producer and consumer, and we create a Spring Cloud Contract multi-API converter. So we can convert APIs based on OpenAPI and AsyncAPI into real contracts. So at least we will have a set of contracts based on those APIs from scratch without nothing to do, just only configure the system for that. So the ACI multi-API converter can work without the multi-API generator. So let's focus in this component. We parse the AsyncAPI file. We create the contract based on the defined operations. We create the stat based on the sample provided from the AsyncAPI file, or in case you don't have defined any examples, because you are in the early stage of the definition, we will generate random data matching this definition. Ideally, you should put examples on your files in order for document. Okay, remember that. But you know, sometimes it doesn't happen, that you don't have time, or there is not enough definition, but your teams need to be working quite soon because the deadline is almost there. So you define the AsyncAPI and keep working. So in order to avoid you waiting for, we generate some random database on. Okay, you want to see how it's working? Let's gonna do a demo, and we'll see later how it works. Okay, then let's gonna do a small demo to see how our tools is working. So we're gonna show you how the apes can create their own business and conquer the world. So now I am moving to the presentation thing. Here we are. So As you can see here, we have an AsyncAPI version 2.3.0. Have our info about the banana petition service. Okay, this is our API. And here we have a couple of channels. The account channel, so we will have our ape accounts that will send through different systems. So we have our petition. So here we will receive our petitions, okay? And here we will receive the new accounts. So this will be an ape account. So this channel we're gonna publish all the information about the account that has been created and has been updated. We received the petition for bananas in this channel, so we are subscribed here. And our account system or user system or whatever system that apes have in place, they will send the new account using the same ape YAML here. So check it that we are referring a new file that is here in this place. So let's gonna see what is inside. So here we have an ape account event. This is an object with those properties. It's normal AsyncAPI file. Here we have a pattern that we use later on, but you can see that here we are defining something interesting, okay? In this one, we have the banana petition. So here we have another object, it's a normal object. So we have an example, okay? As I told you before, you should have an example every time. We define floats for the amount. We define the petition type, that is car, cash, credit, debit. We can use also PayPal for the apes. They are very modern in the last times, okay? And nothing else here. So yes, my POM file, we have here two things. First of all is our Maven plugin for generate the code. So this is the group ID artifact. This is the standard configuration, and here we can specify the spec files. Sorry. So here we are specifying the file for our AsyncAPI. We are choosing the IDs of the operation that we will consume, and we define the ID of the operation that will create an string bridge, meaning that we will not follow what is specified in the event API. By default, we will say if you have a publish here, we will create a producer. If you have a subscriber here, we will create a consumer. But we allow, in case you are using this API in the other side in the other part of the communication, to specify to produce in the subscribe operation. So with only one file, we can cover both sides of the saga or different sagas. We configure here the API package and the model package, so all the classes will be built in this path. The model will be here in this path, and the same happen with the string bridge. But what about the contracts? The contracts here, we are using Spring Cloud contracts, so our converter is set as a dependency, so automatically we will get the file defined here in this folder, okay? And we will create all the tests necessary for that. The package that will be used for create the testing classes is specifying here, okay? One thing that we need to create is this content verifier base. So this class will be used for create and for running the test in the producer part. For the consumer is another word, is different class, I don't have it right now, but you can see how it works. We can see a producer, and we can see the validation for the consumer part. One thing interesting, we will create, let me put it in that way so we can see each other. Okay, so we have here the operation ID, store petition, new account. We'll create these functions with this name based on new account plus the validation suffix. So here you can put the code for validate the message that you are receiving in the input. Same happen here. Okay, this is a comment for later, something that I will need to show you. So here, when the test will be created, it will call this store petition once the data, once an stub is injected into the system for this specific operation ID. In this case, we are testing the producer, so we are producing a message with this specific class, this specific entity. So here my service will convert it to the message that we will create with the plugin, and will validate that these fields match the schematic that has been defined. So let's show how it works. Let's gonna do the standard baby install, cross fingers to see if something is broken or not, because this is a live demo-ish. So things are running. We have some warnings here because by default, Spring Cloud is also reading YAML files. So, but we got here some warning that the file will not be able to be processed because it's not a standard Spring Cloud contract file. We are working on it. We still have plenty of things to do, but what I want to show you is these two things. So our generator has created the emitter and the listener. For the SteamBridge producer, we have this producer here, and he is waiting for offering this method, so you can have this event and will produce into the account that has been defined here in the channel, as you can see. Excuse me, here. So we already have a code, so can be used to produce messages and inject it into the channel. Excuse me. Regarding the subscriber, we have a subscriber class that configure all the beans for the subscribers, okay? And we offer some interface you need to implement. This interface, what they have is the method defined here for store the petition and for store the new account. Okay, let's gonna close those ones, and so you can see based on the API that we have defined here, we have the store petition function, the store petition operation ID. We will receive a banana petition event that is defined here in this class, that is here, okay? And this will call the object that you have implemented following this interface. Okay, this interface we can see here only have this method. So here, implementing this interface, you will introduce your logic business into the system. So you will receive an event that has been created as well with our plugin. Okay, so this is JSON. We have here the enum type with the values. We have all the methods, so you can have the builder. The builder is also implemented here. So all the code you need to work with this API is already implemented and offered for us to do. Okay, but what about the contracts? Because something I was telling you that is magic, that is fantastic, that is wonderful. Contracts are generated here in this piece of code. So first of all, that we got is the contract that we created in a YAML form. So this input and output message is a Spring Cloud contract YAML file contract. Sorry for the contract thing. By default, if we don't have a regis or we don't have something to follow, we added a standard string validation for the string that we are adding. If there is a number, like here, we added the regex to validate that this is a proper number. So here we will not receive a word or a letter or something. We just will receive a number. If we are trying to push something different, it will fail. Same here, that here we have a regis for testing the ICO daytime. But how we can ensure that this is working? Well, here we have the contract class is extending the verifier that I showed you before. Let me close here and there. So this account emitter is triggering a method with this payload, okay? So here we have the when part is when triggered this function here. The verifier of the message is receiving in this destination that is also defined in the, let me show you here. We have defined the channel. So we are linking this class to the same channel that has been defined here in the async API. We are converted from this account emitter YAML. And here, when what we're doing is getting the JSON from this specific response, okay? Once we have it, what will happen is this message will parse against the regis that we have defined in the account emitter. So here, let me put it one side by side. Here we have it. So this regis that we have defined here will appear in the matched part of the string. So every field that has been created and pushed in this schema will be validated. Same happen with the number, same happen with the string, and also the same happen with the time that we have here in an ACO format, right? So this is regarding the producer part that we have triggered here and called it this test. What happened with these two? As I told you before, when you create a consumer, there's only a consumer without output method, meaning a sync method. So we will create a message and we will put this message into the system. So we create the input message based on the payload with the headers and so. We inject this message into the same channel that has been defined here, okay? Following the contract that has been stipulated in this file here that we can open right here because it's beside us. So why I am doing that? Because this message, this contract function, what it makes is validate that this input message match this specification that we have here. If we have any match in that case, we don't have any match, so it's okay, we are doing. What happened here? Once the message has been sent into the channel, we will call this function here, the store petition validation. The store petition validation is one that I implemented here. So using the verify from Mockito, I will catch up the parameter that called it from this method. We get the value and we make the assertion. So you are sure you are asking about these two lines. Well, let's gonna do a break here and go to the code. In the code, we have our listener here. In this case, is the banana listener. So my banana listener is this class that is implemented the store petition that we saw earlier that will receive the banana petition from the channel, because this is a bean that you know what is doing. Okay, so here we have the petition process service that will handle all the petitions. So once this method is called, we will save the petition, we will increment the counter, and with some login. So here you will implement your specific business logic, right? The thing is that because we have defined that as a mock bean, this is a mock, so we are capturing the parameter that we are saving. So here we have a mock, we are calling the save method, but here this object that we are creating here is captured by this argument captor here. So once we get it, we can validate and assert all the values and blah, blah, blah. Same happens with the new account validation. That is the next method that we have here, okay? So again, we create the contract. The contract also validate that the method that we created is according to the definition here. It's sent it into the channel. We receive it in our code because we have here a mock. We capture the input. We get the value from that, and we validate that it's not null. Okay, this is not a super complex validation, but this is only for the demo. If we want some complex validation, we just need to open and comment this code and do some import thing here. And let's see, is this one here as well or not? I think I make a mistake here, yes, because this is the event one. So now it should be something like I think it should be is the banana petition event point petition type. So now we are a square. Okie dokie. So what happens if I run this test here? Because we can run it this straight away from here, so we already have the code and inside the unit code. The IntelliJ start doing his magic, compiling and so blah blah blah. So we start working, and if we have a run, we can start doing the noises. Okay, all tests are passing, but this one is failing. Why is failing? Because the validation is failing because we are expecting to find 10.45 as float, but we are getting these kind of things. Oh my goodness, why this can happen? Well, we can start discussing later, but this is like a problem with Java regarding how it represents the floats, and so this is a problem that you need to solve. I mean, doing the proper conversion and here, but let's gonna do from something more easy. Let's gonna change here for a 10 because we want here a 10, and in the banana petition we can send here a 10. So if I make another install, I will should get flagging colors. It's compiling, doing the test, and the test is failing. Oh, because the test does 0. You can see that we are really testing what we are expecting and what we are we are receiving. Now it's complaining because, oh, the dates is something that is always. Okay, what is failing here? The dates. So we have here an apply date null, and here I have a movement date and apply date. So let's gonna go to my validation thingy that is here. So what I can see if I am receiving a banana petition entity that has this kind of validation field, petition number, but here I don't expect to receive any data. In that case, I am receiving data, so this should be my minimum data to validate because it's the thing I am receiving, but here I don't consider any data. I can add it here some functions to validate the data in case this is random data, or I can come here to the banana petition and add some examples for the data, and blah, blah, blah. There are different solutions, but my point here is I am receiving two fields that is mandatory in the contract, moment data and apply data, and here they are not expecting, so the tests are broken. Let's say that someone is modifying the contract with some real data and adding more field that I need as a producer, or in this case as a consumer, I should receive, but I don't taking care of. My test will grow, so I will notice that something is wrong. I need to implement something like that. Okay, guys, let's gonna move to a new thing I want to show you. Let's say here, another test I have defined. Here I have an account number. The account number now has a pattern that needs to be fulfilled. If you can see here, the account number that I am sending in the meter has an account number DDDD, but someone has came to the API and defined a format, okay? So now everything I generate will match this format here, meaning that my contract here will move from this regex expression, okay, to the new one that is in the file. Okay, so now I should see how these things break when I execute it. So I validated the test. And my account emitter is failing because my expecting actually is DDD and it doesn't match the pattern, 1 or 3 O's and some numbers. So let's gonna replace the field that I am using, so 000023. That should make the thing. I think so. Let's gonna try. Executing the test. Still complaining. Okay. Yes, because I am a bit dumb myself. The 2 is not in the regex expression. So yes, we are sending more or less the same, but we are still not matching the same expression. So here, that you can see, there is not only numbers, it's numbers, but with a specific format. Okay, let's gonna try again to see how the thing is working. I cannot tweak the system. Okay, now it's complaining because I expecting 1, 2, 3. Okay, that's my problem. The problem is the piece of meat between between the chair and the computer. So the expression say number between 3 and 9, okay, and a 2. Number between 3 and 9 and a 2. Let's gonna try again. Hopefully, I will become smart, maybe, and a smart ape. Flooding colors. Now we are generating a contract, an object that is matching all the specifications that we have here. So as you can see, just in build time, I can verify that the information that I am sending is the one that I am receiving. And if you can be able to get your teams talking together, the front end, the back end, or the other microservices, and define the API first, and then we can generate a contract, so you can start working really, really fast instead of waiting because one team doesn't have the producer, other team doesn't have the consumer. So I think we can ensure that the speed of the development will be something improved and really great. So this is for us. This is the demo that we have. So if you have any questions, now is the time to do it. So thank you very much for hosting us. And here I will be waiting for your questions. It's a pleasure to show you our tools. Thank you very much.
All right. Thank you so much, Jose, for this wonderful talk. I'm sure a lot of people have learned from you. Would you like to say
Thank you for you.
something? Would you like to say something to wrap up your call? Your talk, sorry.
Well, sorry, we have those two tools in our GitHub, so it's open source. Everybody can use it. Everybody can criticize and also collaborate with them. Just because we were working with different APIs at the same time, we decided to make one tool that handled all of them. That was the main reason that we create this multi-API tool. So it's absolutely, they're still under development. There are still math things to do.
Okay, great. Would you mind sharing the link on Slack where everyone can get the tools and the resources?
Sure, no problem. I will share it right now.
Okay, good. For everyone, you can join on under the conference 2022 channel. Jose will share the resources and the links over there. And if you have any questions, you can also send them through Slack. He will be happy to answer all your questions. Thank you so much, Jose, for coming through today and sharing your talk as well.
Thank you for hosting me, for having give me the opportunity to talk to you.
Thank you very much. I hope you enjoy your day or morning.
Afternoon here.
Afternoon. Okay, great. Thank you so much. All right. So we're now moving on to the next talk. Laurent, I hope you're ready. You can wave your hand if you are. Okay, perfect. Let me bring you on stage.
Yes, I can see me.
Okay, great. I can see you as well. How are you doing?
Perfect.
How are you doing?
Yeah, very fine. And good afternoon or good morning, everyone. It's afternoon here in France.
I'm also in the afternoon, but some they're in the morning.
Yeah.
Differences in time zones, eh?
Exactly.
All right. So Laurent will be presenting a session about AsyncAPI recipes for EDA Gourmet. I hope I got that right.
Exactly.
Okay.
That's perfect.
All right. Would you like to say something before we start your session?
Yes, just maybe some words, but I'll give also an introduction at the beginning of the recording. So, yes, the goal of this talk is to give you trying to give you a wide overview of the different use cases where you can use EDA and AsyncAPI because from my experience in the field, I tend to talk to people that are very that were very focused on specific use case, and most of the time we're forgetting about any other use cases where they can apply and use AsyncAPI. So this is a wrap up on different scaled of use cases.
Thank you so much, Laurent. And I'm sure the audience is ready to learn from you, and I'm also ready to learn. And if you have any questions for Laurent during the talk, you can send them through on Slack or you can send them on YouTube. You'll be happy to reply them.
Yeah,
And
sure.
with that in mind, we're going to move backstage and we'll hear from Laurent in a second.
Welcome to this session called AsyncAPI Recipes for EDA Gourmet. My goal today is to give you a panorama of many different use cases where event-driven can bring benefits in your complex enterprise information system. In this session, I'll first give you my opinion on what EDA stands for and what could be an adoption map using AsyncAPI specification. We'll again go through different recipes that highlight the features of AsyncAPI that can be used in different use cases. And also during the talk, I'll try to illustrate those features in a pragmatic way using a tool called Micros. So first, a little bit more about me. My name is Laurent, and I'm working at Google on Daytime, where I support fintech startups, scale-ups in making their application design cloud native. I'm also involved in open source on spare time, being a member of the AsyncAPI TSC and the leader of Micros, more on that in a few minutes. Before joining editors or cloud providers, I was working as an enterprise architect in financial services, so I think I have a very pragmatic background, very pragmatic experience on many topics related to distributed computing, enterprise integration, and API programs. And as mentioned in my talk last year, I like gardening as a hobby, but I also like food, as most French people do, and this topic of recipes. So maybe you're hungry, but before jumping to the recipes, just go back to the fundamentals for a few minutes. What's EDA? And it's pretty simple. It's event-driven for the win. And event-driven, it's a paradigm and bring new concepts, bring common concepts that are all about decoupling in time, decoupling the technology, but also decoupling the space, the location. And it brings new concepts like publisher, sender, or producers, like subscriber, receivers or consumers of events, and of course the main one, the stimulus or the event that are triggering messages. But throughout my experience this last year, I also come to a somewhat provocative question when discussing with customer or colleagues. What does the A of EDA stands for? Of course, everybody knows it's for architecture, but what does architecture mean to you? Is it technical architecture? Is it related to the logic of interaction? Is it the architecture of your information system or the organic design of your application? And wouldn't the A mean application sometimes if you focus on interacting with the user? So it leads to the question, what's an application if you're looking for a user perspective or lifecycle perspective? But in short, those questions make me think that there are different levels where EDA can make sense. Yet, EDA is not a new concept. I remember first meeting it nearly 20 years ago when we were talking about SOA, service-oriented architecture. But at that time, EDA was quite different and was mostly seen as a carrier pigeon. It was not that considered reliable. Remember, it was just the beginning of free-class system and the era of two-phase commit. And at the end of the day, people tend to prefer pure web services or batch exchanges that were way easier to operate at that time. So EDA was just standardized on a few use cases, mostly one usage, exchanging flows with partners or legacy system, and mostly in financial services. And also, even if very similar, all pigeons or EDA solutions were very different because of the lack of standards for describing their usage. But luckily, as you may know with this conference, and as you may now all be aware of, AsyncAPI saved the day, really. It saved EDA. Because this spec has this fantastic power of allowing us to precisely describe every situation. What we used to have in traditional EDA at the information system level, represented here by this API that is triggering an event that can be consumed by an email service on a CRM service. It also allows us to manage what we see in new industry, IoT, edge computing use cases at the application level, having distributed applications with a central hub and distributed devices, for example. It allows you to address what we have in modern application interaction, like streaming applications, having an API that stream event to a browser or a mobile phone. And yes, it also helps specify complex or long-running workflows like loan application, like mortgage application, and so on. So you see that it can apply to a whole range of use cases at very different levels. All these examples and others makes me think about some kind of adoption map for EDA. A map that would encompass the application level or tactical use case, as well as the architecture level or strategic adoption drivers. And it would go from local consideration that may be driven by user interaction or deployment mode, because after all, as soon as you're doing serverless stuff, you're doing events, even if you don't really see them, if you don't really specify them. And this can lead you to more regional ones, trying to optimize resource consumptions or access to technologies. And then to more governed one, where you can find the most large-scale application modernization initiatives or techniques like transformation of monoliths to microservices, for example. And finally, to global ones, when you really see the events as the building blocks for supporting your IT transformation or enabling more agility into the business. Each category comes with its own victories or badges if you manage it as a progression, but don't get me wrong, I don't necessarily see this as an adoption path, it's a map. And in my experience, I've seen people that were really well addressing the part on the right, but totally neglecting the one on the left. So my opinion is that there are benefits to addressing all of these. And of course, with great powers come great responsibility or challenges. And it's not that different with EDA. And we see mainly two difficulties on the field. One comes from the multiplicity of protocols and formats that are supporting EDA. I will not say we're still in the carrier pigeon era, but we now address a wide variety of use cases, and we know that one size doesn't fit all. So we end up with a lot to handle. And the other ones come from the consequent complexity of environments for developing, testing, viewing, QA, and so on. And because we have decoupled things, we now have a ton of runtimes to manage. So the latest element I want to introduce before talking about recipes is this Microx project I'm working on. This is of greatest importance, as I truly think that even the greatest spec needs pragmatic tooling to unleash its value to every actor on the lifecycle. And in a few words, Microx is a tool that help simulation and testing of all kinds of API, including the event-driven ones, through the support of AsyncAPI, of course. How we are doing that? And we are doing that by leveraging the power of contracts and example contract because we are using AsyncAPI and it provides all the syntactic rules in it, and examples because examples provide illustrative real-world scenario for free, and they can be embedded into the spec as well. Most of the time in development, we neglect, or in design phases, we neglect the importance of examples. We let tools generate examples for us. And we have basic examples having random values, having always the same values, but we do think that it's a best practice to pay great attention to examples, because when they are carefully chosen, they can represent real life and business expectations in a very clear way. So in Microx, we reuse these examples to first provide you with simulations or mocks, and we are able to turn them into actionable assets so that we reuse them to realize conformance testing or contract testings. So that's a few words on Microx, and you'll see it in actions in a few minutes. So now that we have our three elements, EDA, AsyncAPI, and Microx, we can deep dive into recipes. And I specifically choose 6 recipes that I think are the most common ones, and that every architect, every practitioner should be aware of. Sorry. As I try to make them a bit generic to encompass the most situation possible, you'd probably need to put some context in here, but I hope they will really represent actionable patterns that you may apply later on. So my first recipe is the examples you always see when dealing with AsyncAPI. It's dedicated to user interaction and how EDA and AsyncAPI can help enhance the user or the customer experience, or at least the experience of the developer that is developing enhanced user or customer experience. So this is mainly a recipe to set up the structure that will be the same for each one. So we'll talk about the what, that are the EDA patterns we'll use and the motivations. We'll go through the AsyncAPI ingredients on the right, the ingredients that can be used to implement them. And finally, we'll have a word on how Microx can help in those situations. So in this recipe, you're looking to make a better user experience, pushing events in real time to the user through the browser or a mobile device. And this one involves the definition of a subscribe operation using AsyncAPI. Subscribe operation means that the users of the API will need to subscribe a channel to get the events, to get the notifications, to get the messages. But you can also specify user-led interactions using EDA and AsyncAPI. Imagine you want to implement a chat room or something like that, and this time you have to define publish operation on a channel so that users can send messages. And because AsyncAPI had this notion of protocol bindings, you'll be able to precisely describe the one you choose. It can be a simple HTTP for server-side events, for notifications, or it could be AWS a simple notification system for mobile, or even WebSockets in the case of a chat. So AsyncAPI is very flexible for that. It also allows you to handle different content types for your messages, but in that case, you'll probably end up with JSON encoded messages. How can Microx help in that? Well, let's focus on a simple point for the moment. Microx will be very helpful, allowing you to speed up the work of the front-end team while the back-end team is developing the notification system, for example. So we are going to see how Microx can bootstrap your AsyncAPI. It's demo time, and hope the demo god will be with me today. So let's switch to the Microx. So This is the UI, the dashboard of Microx, presenting you the different API that are in your system. And Microx is very contract first driven. We promote contract first approach, but we recently developed this new feature to allow you to having a rapid feedback loop on a new API. This is called Direct API. Direct API allows you to choose an API type. Here we are going to choose an event-driven API. And we are going to publish our notification API. This will be our first release, 0.1. And we are going to handle notification simply. And with Microx, as it is example driven, you can just specify one example that is the reference payload that will be used to produce simulation and to produce your async API. I can use specific notations in Microx. Here, for example, I want to generate a universal unique identifier for each event, for each message. And here I want some randomness, generating a first name to greet the newcomer in the chat. So I'm gonna hit the next button. And if everything is okay, yes, I got this new notification API that's just right here. So Microx has bootstrapped an async API specification for me. Okay, this is your async API file, and you can have access to the documentation. It has generated a subscribe operation with different bindings, and you can see that by default we have a WebSocket binding just right here. So copying the WebSocket endpoint right here and just testing it, I have developed a basic chat front end, and I can connect to my Microx service and hopefully start to receive messages. Not yet. Let's refresh things. Hopefully it doesn't work. Oh yes, it works. So you can see with Microx I can really quickly bootstrap my EDA project, really bootstrap my async API project, whether for WebSockets or other bindings. Here, for example, the Kafka bindings I will talk about in a few minutes. So this I have some endpoints that are generated for me so that UX team can start working on. And I have also a basic contract that has been generated for me, and I can start to enrich it to complete my use case. So let's get back to the presentation and move on to the second recipe. How EDA and Async API can help on resource usage optimization. This is a very hot topic today, as most traditional companies are moving to the cloud and they are trying hard to lower the cost due to the current context. And this is where EDA can be used at an application level as new programming patterns emerge. So we are talking a lot these days about reactive programming that is using techniques like non-blocking I/O when talking to databases and dependencies, but reactive also introduces a lot of asynchronous ruptures to avoid having threads waiting for processors in the chain of invocation. So in this type of design, each processor you can see in the chain will benefit from clearly defining its interface through an async API publish operation. Of course, you will have to proceed in reverse order. Last processor publish its interface and so on, reverting the chain. And in the case you were implementing the request response paradigm this way, this is something we used to call stage event driven architecture when using queuing technology in the past. Async API also allows you to clearly define a correlation identifier that may be used to match the outgoing response from a subscribe operation this time. For this type of situation, you may want to choose some kind of traditional broker like RabbitMQ or IMQP, as those patterns may require durability, but not the long-term persistence of messages. So also on the side of message content type, AsyncAPI has also first-class support for Avro messages that are binary encoded. So this is very interesting for performance here because messages are internal to an application and not necessarily read by humans. So you can have a bet on Avro for performance, but JSON is still an option though. Regarding Microc's usage in that case, you can easily use it for testing different processors in isolation to each other. Therefore, it becomes straightforward to define a set of example message corresponding to expected input and output. And using Microc's testing features, you can really spot buggy processors in your chain. So let's see that in action with our use cases. So as a developer of a processor, I can easily get incoming messages without having to wait for the previous processor to be ready. So if I go back to my notification API I've used previously, I can, for example, see that there is also a Kafka binding that has been provided. And I can easily start to browse the Kafka topic that was created and managed by Microc. So as an example here, I can just, here using the KCAT, yes, the KCAT tool to see that I start receiving messages and I can start developing my processor. So very, very easy. Now, let's imagine I have developed my processor. And it should respect this user signed up API, okay? And I can test this processor very easily. So let's imagine I start this processor. It is a producer and it produces messages on my topic, on a local topic called user signed ups. You can see here an outgoing messages. And using Microcs, I can easily test it out. So for example, I can launch a new test specifying a Kafka endpoint. Here, the endpoint that is used by my application. I can say that I want to check this operation and I'm using an AsyncAPI schema runner. And what Microcs is going to do is to connect to one or different brokers in your ecosystem, in your environments, and it will start to collect the different messages that are sent on this broker. And for each and every message it will receive, it will check if the message is conformant to the schema. And here you can see that my processor is correct because the messages that he is sending to the broker are conformant to the schema. So it's very easy to spot the buggy processor to check here that everything that you produce are conformant to your API and interfaces you define. So really easy to test in isolation. So now let's go to the third recipe that is about how EDA and AsyncAPI can help legacy and technology integration. We all have legacy parts in our information system, and even if AsyncAPI is quite new, I saw very interesting usages of it in legacy context. Technology integration is quite related to this, as it's basically the same concern of integration and managing unreliable network that pushed us to be asynchronous. So the first use case is about legacy integration. You remember those old MQ series, Webster MQ brokers that allow access to your mainframe? This is what I'm talking about, and I see a lot of people retro-engineering those chains to take advantage of formal description and tooling acceleration that they may have with AsyncAPI. Heterogeneous, unreliable, and long-distance networks are also now a very common case in industry, smart cities, or edge use cases. So this can really benefit from AsyncAPI being there for describing the common part of the interaction, the commands that are sent by the hub to the different device. So this can be done through subscribe operations. And it can be used to describe the data gathering part through publish operation for describing the data that should be sent by the different devices, for example. And here again, multi-protocol support in AsyncAPI is really a big thing, as we are able to support things such as IBM MQ, AMQP, or MQTT protocol bindings. On the message content type side of things, XML is still a big thing regarding those legacy systems, and AsyncAPI can handle XML message as well. And of course, JSON rises in many edge cases where the interoperability between different devices or different device vendors is the key. One thing that I really wanted to highlight today is the usage I see of Microc's simulation capabilities on the field. Having issues with the cost and availability of mainframe partitions for testing, having concern about the availability of remote devices, all this can be easily simulated using AsyncAPI example support in Microx. We see many people building complete partner sandboxes using simple but significant mocks with Microx. For example, in the banking world, a lot of banks are providing open banking sandboxes to allow their partners and their users to play with their APIs. And instead of connecting those sandboxes to existing services on mainframe, some of them have replaced these expensive sandbox environments by just mocks that are served by Microx. So really a cost-costing solution. Okay, just switch to demo, but go to the recipe number 4. Recipe number 4 is how EDA and AsyncAPI can help modernizing a monolith into different microservices, hence managing the complexity that arises. Let's say you have the need to externalize some modules of your application for a better scale or for an easier way to apply changes or refactoring. And extracting microservices using EDA can be very, very handy. One nice thing about event-driven is that it allows you to decouple the place where events are consumed from the place where they are produced. So if you have introduced events between services and modules, you can transparently extract the modules and still have them consume events. And it's then very easy to retire existing modules in a very progressive way. As a side effect, please note that events may also be useful in microservices world to break the dependencies, to improve the uptime and the resilience of an application. Drawback of this being that you may change the way you handle transactions, switching to more loosely coupled methods like, for example, the Saga orchestrations. This may be judged as overkill, but it's really help anticipating the scale up of your application, the scale up of your traffic as you refactor into microservices. So really nice thing of AsyncAPI is that it will allow you to precisely describe your orchestration and your composition process you may implement using Saga. JSON formats or Avro schema embedded into your AsyncAPI spec may be totally appropriated for that. And you can see you can use bindings like RabbitMQ or NAT if you're very cloud native. You still you probably don't need long persistence of messages in that case too. On the Microx side, we can specify that we tend to see more and more the need to use local development laptop situation that allows a developer that can't or doesn't want to be connected to complex systems. For example, in case of mobility or offline situation. And for that, we have also developed a Docker extension for that. So just to give you a brief overview, you can install Microx in a centralized way so that the same instance can be used by different developers, or you can easily use the Docker desktop tool and browse the different extensions in the marketplace and install the Microx extension. That way you have a ready to launch Microx, and it's just as easy as hitting the launch button. And just after that, you've got your locally running instance ready to be filled with any mock you need for your local development experience. So very handy to have this new way of deploying and using Microx. Recipe number 5 is all about pursuing this modularization, but scaling it to the organization level by adopting some kind of domain or product-driven orientation. The usage of EDA and events tend to be generalized as the de facto pattern for East-West communications once you cross the boundary of a domain. Okay, I'm really talking about cross-domain boundaries. And this usually goes hand-to-hand with the adoption of choreography as the way to assemble multi-domains processes in the organization. And here again, there is a lot of interesting things in the pattern called Saga choreography. So I really encourage you to have a look at this. Also, to notice a great approach that we foresee in organization is the definition of all the capabilities of a domain through managed API. Could it be for classic REST API for the command, or GraphQL API for the queries, or AsyncAPI for all the things relating to access of unit or data in unit chunks or in streaming mode. Most of the time we see that the data related capabilities are provided by common infrastructure, common services, common team that handles ingestion, cleaning, anonymization, and so on. And I really think it's also a great fit for AsyncAPI, as such service provider can easily describe publish operations contracts that can be simply reused by all the domains that want to consume these centralized services. On the protocol side of things, AsyncAPI can support Kafka bindings, as we already see. It fits particularly well with the ingestion and streaming use cases, but please note that for this use case, the deployment of a schema registry with either JSON or Avro looks like a mandatory step, as schemas must be available and governed across the organization. We specifically added the schema registry support for Kafka in the latest AsyncAPI release, that is the 2.5 release of the spec. So you should really have a look at it. How can Microx can help you with that? It can help a lot because of its multi-protocol support. We mentioned Kafka in that case, but WebSocket is also of interest if you need to expose some data to the outside of the organization, because please don't provide external access to your Kafka broker. Use WebSocket instead, for example. And as Microx supports both, it's really easy. It really is the pain testing the different exposition. But Microx can also help with the schema registry integration, as it is able to connect to the central registry for automation of the publication of the schema updates. And it can also connect to distributed registry to test that the records read from different brokers can be correctly deserialized using a corresponding schema. Let's see that in action here. So, for example, I got a schema registry that is connected to my current Microx instance, and this registry is empty at the moment. And on the Microx side, I have preloaded an async API that is handling Avro messages. Okay, so you can see there is an async API spec, and there is an Avro schema that is attached to this spec. Here is the schema. So Microx can publish MOX message. For now they are disabled, and you will see there that as soon as I enable the publication of mock message, it will also handle the synchronization of the schema registry with the corresponding schema. So let's check. With the property addition, I can now enable the mocking. Just save here. So it should start mocking, sending new messages, and as soon as it has started mocking, if everything okay, yes, it has synced our registry with new schema that is attached to the async API specification. So it's very handy to ensure the propagation of your schema on the registry. And as Microx can be also connected to your Git repository, as soon as you have updated your async API file into your source of truth Git repository, you can be sure that it will be propagated to your schema registry as well. And here we are finally on recipe number 6. And as a cherry on the cake, I wanted to finish with this one, talking about how EDA can be used in large scale to provide some help in a move to cloud transformation. Because in move to cloud, there's usually this problem of data gravity. You want to start with the easy part, moving one application to the cloud, but the data is still on premises, used and produced by so many other apps. So, as said before, one nice thing about events is that they are easy to replicate, and you can decouple where the data is produced from where it is consumed. We already saw that, and in that case, let's imagine I have my on-premises and my cloud environment, and the first things that we have to do is to set up a replication of events to the cloud or to the clouds of my choice. For that, I probably select a globally available broker like the one from Soleil, from Google PubSub, from AWS, or even Kafka with mirroring, for example, if you're managing different regions. And the nice thing is that we support all of them in AsyncAPI. So once the replication is done, you can start deploying new consumer C on your cloud provider. This is transparent, totally transparent. Then you can move adapted consumer B on the cloud before retiring it from the on-premise. And when finally you are ready or you want to move the service that is on the top, you just have to move it and to revert the replication. Okay, now the master is the cloud environment and events are replicated to the on-premise environments. Finally, you can retire your on-premise services, and maybe the consumer A that sticks on premise or that will stick on premise forever continue to receive environments in a very transparent way. As with the previous recipe, Avro and JSON with schema registry are perfect candidates for that. But note that it may also be of interest to consider something like cloud events that can ease the registration or the interoperability of your own events with the one of your cloud platforms you chose. And luckily, AsyncAPI is also compatible with cloud events, as I described it extensively in a previous talk last year. So you may have a quick search on YouTube search for my name and Cloud Events or AsyncAPI, and you will probably find this detailed video showing how they can be combined to provide great power and great interoperability. Finally, where to use microx in this picture? And I would say everywhere, of course, because it also supports the different bindings and support cloud-based broker. So it could be of great help for anticipating and preparing migrations, as well as ensuring there is no regression once you've started moving components or revert replications, for example. So basically, you can see micros everywhere. So time is flying, and it's the time to wrap up things. So as you said, it's a journey, and if I succeed in my demonstrations, you now understand that EDA plus Async API plus Microx can be a very helpful combo in a lot of situations, from purely tactical to more strategic approaches. As said in the introduction, I chose today to have a very progressive approach, but this is not necessarily a path. This was easier to have this progressive approach to introduce concept one by one. But you can really start from the right and then also consider recipes on the left. Start having a global approach and then a local optimization approach, or going the other way. It's really up to you to, let's say, to build your own menu, depending on your scope of action, depending on the maturity of your organization, and a lot of other criteria that matters for you. Just final words of Microx. We are open. We welcome everyone to come to share ideas and to contribute. The project is purely community and user driven. So this last month we implemented a lot of stuff regarding users' requests, regarding the supports of new broker, the supports of new approaches of testing approaches. So it's really up to you to come and join the community. Try it and give us feedback. And this is the final words. Many thanks for attending this session. I hope it has been worth your time, and I hope to see many questions in the chat. Bye bye.
And thank you so much, Laurent. This was very informative, and I learned a lot about Async API, EDAs, and Macrox, and I'm sure the community and everybody else learned a great deal from you. And so to wrap up your session, what key takeaways would you like to mention or to give to the community and to the users?
Yeah, so just to repeat some piece of my conclusions, yes, I wanted to show here that there is a lot of different use cases where EDA and Async API can shine. I realized during the preparation of the talk that there was in fact a lot of other recipes, and I have to select and just to pick 6 of them. And now I've got a lot of material for a blog post series and so on. But yes, I wanted to show that it can go from very scoped, very narrow concerns regarding user interaction to very broad, very wide strategies around microservices migration, cloud migration, and so on. So yes, I hope you've enjoyed these different recipes, and I think there is a lot of material for some of us.
That's true. And if you want to speak to Laurent, if you have any questions, please join Async API Slack. I'm sure the link is shared on the YouTube platform, Twitter, and the socials. And you can also DM. I'm sure anyone who wants to have any questions for you, you can DM Laurent. He's available on Slack as well. And you can also check him out on hashtag conference 2022 under Async API. Thank you so much, Laurent, for your time today. And we hope to see you next year as well with more recipes.
Yeah, I hope so. Thanks a lot for the opportunity.
Thank you very much. And with that in mind, we're going to take a 2-minute breather and usher in our next guest, Ismael, who is going to give us the next talk. Please stay tuned. All right, and welcome back. So we have Ismael on our next talk. He'll be giving us a talk called "The Future of Messaging." Ismael, if you're ready to come on stage, could you give me a wave? Okay, perfect. How are you doing?
Hello, I'm very well, thank you. Really good to be here.
Thank you so much for making the time to be here as well. I'm looking forward to your talk. Would you like to give us a summary of what you'll be talking about before we start?
Certainly. I'll be looking at something called delay tolerant or disruption tolerant networks, which is being used to build the interplanetary internet, but also it's being used more locally, so to speak, in our planet to reach those very hard to reach and cut off communities which don't have easy access to the internet, for example, or in the middle of the ocean, ships, etc., wherever the connections are very poor. And it uses an approach called store carry forward, which is a growing paradigm in networking. And I will be exploring whether and how far AsyncAPI could articulate this new approach and bring to that new community, so that the two communities of delay tolerant networks and the AsyncAPI community can begin to talk to one another.
That's perfect. I'm really looking forward to your talk today. And Ismael will be presenting us live. So if you're ready, the floor is yours.
Thank you. I'll just share my screen. Can you see it okay? Just checking on this platform. Yeah, I think so. Okay, well, really fantastic to be here. I love AsyncAPI. I came across it a few years ago and became a fan of all its possibilities and the amount of progress since then, when I sort of just came across it in Postman Galaxy, and today with the full Linux Foundation and a huge community of volunteers, it's been a very inspiring thing to watch, and it's one of the most efficient, effective, and friendly, welcoming open source communities I've had the privilege of being involved in. So it's a great thing to be here with you all and to be learning for the incredible talks and to be sharing some thoughts. about myself, I am the director of the Adora Foundation, and I'm lead researcher right now at the Green Software Foundation, working on the State of Green Software report. And software engineer by background, also social entrepreneur, and very focused on sustainability, and particularly the role of tech and digital emissions on the environment and what we can do about it. And that's what led me to really begin to explore this delay tolerant networking, as I will explore or explain in a minute. So delay disruption tolerant networks. When do you use them? You use them when messaging involves very high latency. Think Earth to moon latency. Or where there's very low data rate, or a lot of disconnection, think the middle of the ocean, or limited connection range. I once lived in a very remote Maasai village, and they had phones, mobile phones, maybe 2 in the village. They had 1 cassette tape. I spoke about this in an earlier AsyncAPI conference, but they had very low connectivity. They weren't within range of Wi-Fi and similar. And so this is another use case. And then what is called time shifting in carbon-aware computing. So the electricity today is a mixed thing. It's mixed between dirty fossil fuel, coal burning plants and green renewable wind and solar and hydro powered plants. And the problem with nature is that you have to be a partner. You're not really an owner or a controller of nature. So you can't really decide when the wind will blow or the sun will shine. And therefore, during any given day, the electricity will have moments where it's mostly powered by renewables or only powered by renewables, and moments where it's mostly or only powered by dirty energy. Time shifting involves making sure that your computing only happens at the times when the electricity is cleanest. And therefore, this notion of delay or disruption tolerance can be helpful. If your gadget or device is can process the information or receive the messaging at clean times and doesn't have to be on at all times, this will be another great value. So delayed disruption tolerant networking is an approach to routing messages in an asynchronous way, hence AsyncAPI, and in an event-driven way, but in a way that does not require a direct constant link or range of connection. So it uses something called a store carry forward relay routing architecture. And I'll explore a bit more what this means in detail, but it's the idea that you don't just send the signal, you don't just send the signal, store it, and then convey it to your subscribers, but you can convey it to subscribers, which then carry it on to another area and hit subscribers in that remote area that are connecting not to your original source or your broker, but to that mobile device, for example. So it is used for the Internet of Things. It is used for vehicle-to-vehicle communication, for carbon-aware computing, as I mentioned, and areas where there is very low infrastructure. In hard-to-reach locations like outer space, mid-ocean, and remote regions, or in sort of easy-to-reach locations, but in circumstances that impose interruptions, latency, or delays. So this is a paradigm that I think we are pretty familiar with in event-driven architectures. The message goes to a streaming service, and the streaming services publish it to all subscribers within range at the time. So if that message is being streamed at 11, anyone who is connected at 11 a.m. will receive that message because it's just forwarding it on. The device number 2 that logs in at 11:30 will not have received that original message. So it's like jumping in halfway through a terrestrial TV program. You are just hitting it at the point you're hitting it. So the previous messages are gone. Another paradigm that is very familiar is the store forward paradigm. So a queue is a good example. So the message goes into a queue, and then all of the subscribers will receive that message as soon as they connect to that queue. So it could be at 11 a.m. and then someone else comes at 11:30 a.m. and they get their SNS notification or whatever it is that you are relying. So here, your broker is not just forwarding, but storing. So the architecture is a store forward paradigm. Device number 3 is out of reach. It is never going to connect to that queue. And so it will never receive the message, no matter at what time it connects, because it will never be in range of that broker. And therefore, the store forward mechanism will never reach it. And that will be the case whether you are in the International Space Station or in a very remote village in Bangladesh or in the middle of the ocean in your cruiser. So store carry forward will send the message to your queue or your stream. It doesn't matter. I think it should say queue because I've got a device there at 11:30. So it's the queue, and it will send it to all of the subscribers that come on. So this device number 1 gets it at 11. Device number 2 gets it at 11:30. And there's a moving object, which is a device. It might not be an end device. It might not even be a kind of a destination device, but it will store the message and carry it. And when it's carrying it, it will now be in range of device 3 and transmit that message. So that device 3 never comes in touch with your broker, is never in range of the message, but it still receives it via that moving object that stored it, carried it, and forwarded. And this is a powerful paradigm in so many ways. So the internet, for example, requires all of the protocols to align in order to stream one message from your server to the end device, for example. And that can create an element of latency. With a store carry forward, you might just store the first layer until that second layer aligns with the next layer and not necessarily with the first layer. And that will mean that you can actually send a lot more messages in between in an asynchronous way. And that's why it is of such interest for interplanetary communication, which is where the paradigm started. So it began in NASA, it began in space research, it extended with DARPA into defense and therefore into terrestrial applications. And then it went beyond defense and space into all kinds of uses where these paradigms are useful. So there are a number of relay strategies that do not necessarily reflect this kind of streaming API from Twitter to the browser. So instead of just that direct communication, your intermediary objects, that moving object in between, it could be an opportunistic relationship. So if the browser is entirely out of reach of Wi-Fi, for example, it may be that you are relying on that moving object is a random mobile phone, and you don't know which mobile phone will be in range when. So this is an opportunistic relay. You're basically looking out for any device that is willing to carry your message, and sort of you'll send it potentially to lots of devices all of the devices there, so that they in turn opportunistically relay it to end devices that happen to be along their route. Or it could be a cooperative relay strategy. In this case, you have very specific devices that are cooperating. So you're not waiting on a random mobile phone. You know that there is going to be a train passing at the same time every day in the same place, and that train will be passing through a neighborhood that has no connection to the internet normally, but will be in range of that train for just enough time for that train to receive that Twitter message. There's probably more important things you can do with it. But that's just one example. So here you have a cooperative relay strategy where those machines are consciously cooperating with you to send it. And finally, you could have a competitive strategy where there are perhaps some time pressures or perhaps priority of messaging, etc. So you might have 5 potential machines that are collaborators that you know are going to go there, and you send it to all 5, and the one that gets there first transmits it. It's also not all or nothing, for example. It could be that part of the message is streamed by that first train, and the last part of the message is streamed by a sort of drone that is passing, etc. So there are many architectures that you can create depending on your use case. And people have created sort of a mix of all of this, where you use opportunistic mobile phones, but you also have relay boxes in between, so that the mobile phone transmits it opportunistically to a relay box that cooperatively transmits it to another relay box, where you potentially have a central point that has that treats different relay boxes in a competitive way. And this is, for example, a use case in disaster communications, where you might have sort of emergency services with their own backup communications infrastructure in the middle of nowhere. And they are integrating multiple streams of information and then communicating an integrated narrative back to headquarters. So there's a lot of possibilities around these. So I mentioned here a few examples already. Now, this is important. For example, at the moment, most of our Internet of Things is very energy and communications dumb. It is basically on all the time, even if it only needs to be on for a particular moment of time. And that means that it is generating digital emissions. It is burning through battery when it might not need to. So being able to identify which connected devices could be delay tolerant is hugely important. Likewise, connected devices are very often mobile, and therefore being able to identify which connected devices could act as carriers for signals and therefore bring in our messages beyond those people who get to connect in range of whatever infrastructure we are using to communicate, again, becomes quite instrumental. So designing connected devices that can both be delay tolerant and also act as carrying relays, both for messaging that is directly relevant to them. So it might be that you have a watch that requires to receive messaging for all of the apps that are running on its smartwatch. But it could also be that you are an altruistic, that I forgot that paradigm. That's another paradigm, is altruistic delay tolerant network. So your phone, for example, your watch, for example, might agnostically say, I am happy to take messages in general. And there's thought around security that has been going on, and in fact, it's been sort of built into a lot of the networks from the start. It might be that it's a subsection of signals that you're open to, but essentially you are saying, I'm open to signals that don't benefit my user, that benefit third parties. And my user is happy to use his watch for that. So that's another way in which connected devices, Internet of Things, would be using this paradigm. Vehicular networks, vehicle-to-vehicle communication. This is something that is growing in significance as IoT, as electric vehicles, as smart cities, smart networks. All of this ecosystem is accelerating and does seem to be the face of things to come. We are not yet at a point of having reached critical mass, so a lot of this vehicle-to-vehicle networking is still at the proof of concept stage. But in whatever scenario we are looking at, then delay-tolerant networked communication and routing has a potentially very big role to play. So the idea would be that a car, for example, that is coming in the opposite direction from you will have information about traffic conditions ahead of you. And so that car could communicate with your car to transmit that information, which in turn is aggregating the input from that car in the opposite direction with all the other inputs it has access to and transmitting them to other cars, which means that the level of detail and richness that you can get in terms of road information is incomparable in relation to what we have today. So this would make self-driving cars, for example, inconceivably more safe and accurate and powerful. And there are, of course, non-vehicular advantages to being able to create such dynamic mesh networks between cars. Carbon-aware computing, I have already sort of mentioned it. So this could apply to your connected devices, to the Internet of Things, or it could apply to your software. So if a particular process, or more specifically in our case, a particular subscription to a message is not time sensitive, then you could describe your APIs in such a way that that transmission only happens at times when the electricity grids, both in the emitting, the publishing side, and the consumer subscriber side, are at their greenest. So if you could create a set of APIs that communicate with each other, not just in terms of their task, but also in terms of, for example, their level of battery, but also in terms of their emissions and the grid and the local electricity conditions. This could be a game changer to the gigantic contribution that our sector is making to climate change, and where most other sectors are gradually diminishing their contribution to climate change at the moment, not fast enough to avoid really painful scenarios, but decreasing. Our industry, the digital technological industry, is still growing. So the data that we're using is growing. The electricity we're consuming is growing. We are becoming more efficient, so we are consuming less energy per process as time goes by. But our growth is so extensive that our net emissions keep on growing, even if we become more efficient. So being able to be carbon aware in our devices and describe that in some way and ensure that our communication imposes delays as opposed to tolerate delays, welcomes delays, embraces delays, but does so in a way that is coordinated and that allows us to essentially run on green energy, which will give us more and more availability the more and more we green the our energy consumption globally, then that's fantastic. And finally, I have mentioned examples of low infrastructure. This is a case for digital inclusion. At the moment, in spite of this tremendous mark that we're making on the world positively and negatively, 50% of the planet is not connected. This is huge. And given what happens on the internet, what happens in digital life, that digital exclusion is a financial exclusion, is a knowledge exclusion, is a gigantic injustice. And at the moment, our approach to reaching those hard to reach areas, to connecting those disconnected areas, has tended to be, we just have to grow more, which of course is going to create even more problems for those areas, as they are the main sufferers of the impacts of climate change. So delay-tolerant networks are a paradigm that allows us to envisage ways of creating connectivity in areas of the world that are currently excluded from the digital conversation, without necessarily having to think about investing in major infrastructure projects in every single area and major servers and all of these things. So being able to create more distributed processes is that next civilizational step, as it were, that I described in my last AsyncAPI talk, this sense that we are moving toward a much more nuanced, reactive, distributed, event-driven society, and not just technology. So what are the cases for AsyncAPI in delay and disruption tolerant networking? As far as I have been able to tell, I haven't come across any use of AsyncAPI in the delay tolerant networking community. And this is a pity on both sides. I think that AsyncAPI has a huge role to play in the paradigm that I've just described. AsyncAPI, of course, is there to describe event-driven communications. And delay-tolerant networks are quintessentially event-driven routing protocols. Moreover, AsyncAPI is protocol agnostic. This is absolutely critical because at the moment, we are at risk of a proliferation of protocols. And there will be a proliferation of protocols. Delay-tolerant networks in the Internet of Things will use different protocols for different types of Internet of Things, different protocols for vehicular communication, different protocols for interplanetary communication. So this is on the one hand natural, and it makes sense. You might not want to use the same protocol for your smartwatch as you are using to communicate with Mars. But on the other hand, it also creates a huge amount of complexity and constraints, because one of the key promises of the store carry forward paradigm is interoperability, is this idea that my watch or my mobile phone or my car could help deliver emergency services information in a massive flood or heat wave or earthquake to emergency services and to sort of the central coordination side of the government. And if all the protocols are not able to talk to one another, our ability to do this is hamstrung. So being able to have a language to describe our APIs that is protocol agnostic, that allows my car and my watch to talk to one another and to the emergency services and to the International Space Station as need arises, is really powerful and really significant. And being able, particularly when we're talking about, for example, opportunistic or altruistic routing strategies, being able to say, I am open to these kinds of signals I welcome these kinds of APIs and I am transmitting these kinds of APIs and these kinds of messages to these kinds of servers, this is really important. And at the moment, as far as I'm aware, and I'm certainly not an expert in this field, but as far as I've been able to tell, there isn't anything like it. There is no way, there is thought going on into creating common standards, and there is work going on into thinking about this interoperability, but not in a protocol agnostic way. So AsyncAPI offers to the delay-tolerant network community the ability to talk to one another, not just now, not just for uses they already foresee, but for the future, for all the uses and all the applications that are emergent, that will become possible and that no one can predict, because that is the nature of an event-driven society, that we are using and collaborating and harnessing information from one another for uses that we never thought of before, and that the aggregation of previously unrelated information makes possible innovations and applications that people would not have been able to even conceive or imagine before that data or those information streams could be aggregated. So AsyncAPI provides a language to be able to aggregate these kinds of communications and informations and innovate and expand. And because AsyncAPI has been working on this fantastic tooling, some of which we've had demoed and highlighted in this fantastic conference and will continue to have, therefore, the delay-tolerant network community can also greatly benefit from advances in this tooling to simplify and shorten the amount of work involved in the processes. Most of the delay-tolerant network community, as far as I've been able to tell, tends to be much more hardware-focused than software-focused, and infrastructure-focused than software-focused. And that means that if they had software-focused tooling that could accelerate and improve the quality and the interoperability of the hardware they are building, this is surely a massive win. And in addition to the interoperability aspect that I've mentioned, I think another thing that AsyncAPI can offer the delay-tolerant network community is the possibility of design-first approaches and specification-first approaches. If people already know what the entire data structure and what the entire communication protocol and what the requirements of communication and interaction will be for a particular technology, then an entire ecosystem can already start building knowing that that will be in place, and purely on a combination of the AsyncAPI spec and its tooling. And that will accelerate innovation, and again, in ways that are potentially unpredictable. So if I can read the AsyncAPI spec of the next Samsung smartwatch, I might already know that I would be able to use it for emergency services in conditions of disasters, for example. And I might be able to reach out to the Samsung team and say, hey, this is what we're thinking. We are sort of the United States government. We'd like to be able to do something like this. This is our AsyncAPI spec. Would you like to talk? So the possibilities that design first makes possible, not just in terms of speed to market and sort of defect reduction and all of the values that we already know about, also has a potential in terms of the innovation and collaboration process that this very innovative and networked ecosystem is having and will have. So this brings questions with it to us. Can AsyncAPI, as it stands, describe effectively the store carry forward routing strategies? Can the async API tooling be used for delay tolerant networks? Is the existing spec fit for purpose, or could it benefit from extending? I will not fully answer these questions today. If anything, I think that the main contribution I would like this talk to make in terms of the audience here today, which is async API practitioners and experts, is for you to take these questions forward. I will obviously give it a stab, but really I think this is something that can be explored a lot more. And this is something where I think if the Async API initiative were to create, for example, some good thought pieces, some good materials that the delay tolerant network community could get hold of, ideally collaboratively, ideally with someone from that community, from whether it be sort of, there are some massive networks now outside of just NASA and DARPA, etc. There are equivalents of the Async API, as it were, initiative, non-profit foundations that are having this conversation. So I think if there could be the kind of conversation and documentation that would put this on the radar of this sort of very important part of our emerging technology landscape, this would be huge. So I hope that this awakens the curiosity of some of the people here today to explore this further than I will. Now, looking at this from a sort of a very introductory perspective, and I won't dwell any in detail. You can see I'm using the 2.0 here from the slide, and we are ahead now. So I think the presentations that have been given today and that will continue to be given will sort of flesh this out a lot more. But at a high level, I think this provides, in my view, what you need essentially to describe the core of a delay tolerant network of a store carry forward protocol, because you are saying this is what this application is. This is a store carry forward, and it is being served from here. This may need perhaps a bit of refinement, because obviously if the carry portion of it, that vehicle that has taken the message with it, my understanding is that here it would become the server essentially, because it no longer has any connection to the original server, and it is emitting the message that it is carrying for its publisher and subscribers. So how would you describe the servers is something I would love your input on. Is the server purely the originator? Do we have our sort of, production staging, and along the same lines, would the carrier sort of inject into the server description its own self? I'm not sure, but sort of that's where that would go, right? And then, of course, you have your channels, and sort of that again is fairly straightforward in principle, because essentially every carrier of messages is both a subscriber and a publisher, and essentially a broker, really. And components, I think, become particularly valuable in this paradigm, insofar as they might be reusable cross-device, cross-application. There might be components that can be reused by a whole range of completely independent connected devices, for example, which are intending to talk to one another as part of their protocol. So it might be that the components part of the specification gains importance within specific domains in the delay tolerant networking world. So, if you are using delay tolerant networks for communication with voice at sea, then it might be that even if the manufacturers of each of these devices are completely independent, they might use certain common components for their async API descriptions to maintain interoperability and facility and this design first approaches. Now, the channels, again, I think my intuition, my instinct is that they are good enough as they stand, because you are able to say, I subscribe to these operations as a carrier, for example. I'm focusing on carriers because I think the other components in my diagram are already being used by AsyncAPI, and we know they work. But it's these temporary mobile carriers that are not just publisher and subscribers, but also brokers. But my understanding is that really a broker is still essentially a publisher and a subscriber. So they would presumably have to specify what they subscribe to in order to be able to carry that original message from the broker, and what they publish, and what are the what is the data formats that they publish. And this could potentially be really quite complex. Again, an area where components come into their own, because if you are acting as a carrier potentially for things that you are not going to consume, you don't really care about the data format yourself. You're just passing it on for anybody who happens to use that data format. So again, this is where components could become really valuable, because you might say, I am a publisher of this component. I am a publisher of this component. I'm a publisher of this component. And each of those components might have completely different data structures and payloads and headers, etc., in accordance to the multiple protocols that that carrier may or may not interact with. And so yes, I think I've already mentioned here. And here you have, when we look at the components, you have the schemas, the messages, the security schemes, and the bindings. I think my understanding of bindings is that bindings are the protocol-specific requirements, the requirements that you wouldn't say in a generic async API, that are specific to one particular system that will be using your protocol. So I think this is probably one of the most crucial elements where thought needs to be given. So these are perhaps, this is the place where you specify, for example, whether you are carbon aware, whether you are going to be operating, publishing only when your electricity grid is clean, or, sort of accepting subscriptions only when you hear that the electricity grid is green from your subscriber, for example. I'm not sure, but I do think that this is the area, the bindings area is the bit that makes async API so usable already for delay tolerant networks, because anything that is not covered in the async API specification can be added to the bindings and to the extensions. I think this is very important for those who might be listening to this presentation and are not aware of extensions, the fact that you can take the async API spec and extend it for your purposes. And my understanding is that in the community, the async API community, you might often begin with extensions, and if some of those extensions prove to have really general value and not just for the people who extended it, they might sort of become part of the next universal async API spec. And this is a real opportunity, again, for people in the very emergent, very new, very fast changing delay tolerant network space, because if there's something that is missing or does not quite fit in the current AsyncAPI spec, and that is not handled in the binding section, then you can always extend it. And it might be that when one of these store carry forward implementers extends it in some way, you have 3,000 delay tolerant network products saying me too please, and that becomes sort of either stays as an extension or becomes mainstreamed into the AsyncAPI spec. So I think sort of my summary of this would be to say that that I think we have enough now for proof of concept. I think we have enough now to use AsyncAPI to describe delay tolerant networks and store carry forward protocols. Do we have enough to describe all store carry forward protocols? I'm not sure. Do we have enough to be the best use case for all delay tolerant networks? I'm not sure. This is an area where I really hope this starts a conversation. And more generally, is in this example, for example, without thinking just of the store carry forward protocol, when we're thinking about the carbon aware computing, which is growing and growing and growing and will continue to grow, where would be the best place to do this now? Would it be in the overall present in our sort of description, in our extensions, in our bindings, or is this something that should become part of the AsyncAPI spec, some form of signaling this carbon aware sensitivity to different devices? That's my last question. So thank you very much for having me, and I look forward to whatever conversation ensues.
Thank you so much, Ismael. This was an informative talk, especially when it comes to AsyncAPI and the role that it has to play in store carry forward and delay tolerant networks. We have a question from James. It reads, wouldn't store carry forward be something communicated by the events metadata and not part of the API except as a parameter?
Maybe. I'm entirely open to that possibility, but the reason I would be doubtful is because I think you would want to be able to describe that intermediate layer. You'd have to be able to describe how to communicate with that moving object. So you are not just receiving that agnostically, as it were. It might be that in some cases, yes, it's literally storing the same message for the same end user and it just happens to be carrying it. Then yes, it might just be in the event metadata. But if that moving object is also acting as a broker and it is using multiple protocols, then it might be that you actually need to describe it in a richer way.
Okay, thank you so much. And I hope, James, your question has been answered. Before we close, would you like to say something before we wrap up?
No, just please reach out. I'm part of the Slack group on AsyncAPI. Please tag me because I don't always follow all the threads. Also, it'd be good to just have those discussions. I'd be happy to join a community group to have that conversation further. But if you think this is valuable, then ignore me, take it forward yourself, and get talking to the delay tolerant network community. Wouldn't it be great if AsyncAPI was in Mars? That's where I'm going to end. Wouldn't it be great?
Yes. True. And if you have any questions, if you have any thoughts, any contributions, please reach out, join the Async API community and join us on Slack. Ismael, if you have any questions for Ismael as well, he'll be happy to answer them on Slack as well. Thank you so much, Ismael, for coming today. And we hope to see you next year on the next conference.
Fantastic. Thank you for having me.
Thank you. And with on that note, we'll be heading on a 6 or 5 minute break while we prepare for the next presenter. Please stay tuned.
Hi everyone, my name is Marc Oriol. I am from Universitat Oberta de Catalunya and I'm going to present this talk titled Quality of Service in a API extension with service.
Hey, hello guys. Welcome back. Hope you guys enjoyed this quick short break. So today with me I have the next presenter, which goes by the name Mark. And today Mark will be walking us through in details about quality of service in asynchronous services and the CKPI extension with service level agreement support. So I'll be bringing up Mark upstage now. Mark, if you're ready, can I have a thumbs up? Hey, Mark, you ready? Okay, great. Bringing you upstage now. Hey, Mark, how you doing?
Hi, fine. How are you?
I'm doing fine. Super excited to have you here today.
Excited to be here.
Yeah, I can see your presentation looks promising, and I can't wait to learn, a lot about what it is you have to teach us today. And I'm pretty sure the whole community also is super excited to listen to your presentation. Before we get started, do you have anything to share with the community and with the audience?
Yeah, just that I'm super excited to be here and to be part of the presenting here in the AsyncAPI conference. And I hope you enjoy my presentation and don't be shy to ask questions.
Definitely. I know the questions will eventually come in. So I hope you're ready for the questions.
Perfect.
All right. So with no further ado, Mark, so we're going backstage now and we'll bring your presentation up.
Service level agreement support. In the context of event-driven architectures, we may have several services, in this case asynchronous services, where the service clients can subscribe to several topics or events, and these events are received as soon as they have been generated. However, these systems might encounter problems of quality of service. For instance, we might have latency problems and the events are received much later than it should be expected. Or also we could have availability problems, so the events are not received at all. These quality of service problems might impact not only the final end user of the service client for a particular service, but might also impact the whole architecture, the whole software system where we have dependencies between different asynchronous services. Therefore, we need to tackle this problem and we need to guarantee the quality of service for asynchronous services. And here I underline here asynchronous because in the field of service-oriented systems, and in particular those web services that are synchronous, there is a lot of support for quality of service in terms of service level agreements, monitoring, and so on and so forth. But there is not the same degree of support when we talk about asynchronous services. To tackle this problem, we provide here, or we propose an AsyncAPI extension with service level agreement support. In order to address it, we first need to do two steps. The first one is we need to identify what is the quality that is relevant for asynchronous services. What are the characteristics, attributes, and metrics that constitute the quality of service for this type of services? And when we got that, the second question is how we can define conditions over them in order to ensure that the whole system works as expected. Moreover, what we want is to provide these features seamlessly integrated with the AsyncAPI specification. So let's go with the first step, identify the quality. So what is quality in the field of the asynchronous services? What are these characteristics that are relevant here? Now, in order to identify the quality, first we need to understand how quality of service can be structured. So here what we have is that the quality of service is structured in a hierarchical way in different categories. So the quality of service, we may say that is the totality of the quality characteristics of a service. And these quality characteristics, for instance, could be performance, are groups of quality attributes. So for instance, for performance, we would have things like time behavior or resource utilization. The quality attributes are features of the service that affects the quality, and they can be measured in terms of quality metrics. So for instance, if the quality attribute is, for example, this time behavior, a quality metric would be, for example, the latency of the web service. So quality metrics are the quantitative or qualitative measurements for a quality attribute. Following this hierarchical structure, there have been several proposals, and these proposals are basically quality models that instrument and characterizes the different quality characteristics, attributes, and metrics. The standard for the software systems of product quality is the ISO 25010. So here we have in this standard that the software product quality it has several characteristics such as functional suitability, performance efficiency, compatibility, and so on. And for each of these characteristics, there are several quality attributes. The problem with this model, if we want to apply it in the domain of asynchronous services, is twofold. On the one hand, it's for software systems, so it's not specific for asynchronous services. So there might be several attributes that might not be here, or the other way around. There might be here several attributes or characteristics that are relevant for a software system but not for asynchronous services. And moreover, this quality model doesn't go deep down to the level of the quality metrics. So we have quality characteristics and attributes, but it doesn't go down to the level of metrics. To address this issue, and as part of our previous work, we conducted a systematic mapping study where we revised the scientific literature of quality models that are specific for services. And what we did is we analyzed these quality models, 47 of them, and we integrated them and mapped them into this ICO standard. So basically what we did is for each of the quality models that we identified in the literature, we integrated all of them and basically, as said, we mapped them to this standard. Here it is an example of the mapping that we conducted. So here we have the list of an excerpt of the quality models that we studied. And here for each quality model, we identified to which degree they support the different characteristics and attributes of the ICO standard. And for each of these attributes, we identify different metrics. So for instance, for the attribute of functional correctness, there might be metrics for correctness, precision, transaction integrity, and so on and so forth. And this was done in the field of quality models for services, but not specific for asynchronous services. So if we draw a Venn diagram, and yes, this is actually a Venn diagram, what we can see is that we have the quality model for software. This is the standard ICO 25010. This is the result of our systematic mapping study, where we have a quality model that is specific for services. And what we want to achieve is a quality model for asynchronous services. So what we have done in this work, we have basically looked at the quality model for services that are services of any kind, both synchronous and asynchronous, and identify those characteristics, attributes, and metrics that are relevant for the asynchronous services. Here is an excerpt of the different attributes, metrics that we have identified that are relevant in the domain of asynchronous services. So for instance, for time behavior, obviously there is no such thing as response time because there is no response to provide in this kind of event-driven architecture, but there are several metrics in the time behavior that are relevant, like the latency, the round-trip time, if there is ACKs in the messages, the jitter, the throughput, and so on. And here we have a list of different metrics for the different quality attributes and the quality characteristics. Now that we have the list of these metrics, attributes, and characteristics that are relevant for the asynchronous services, we need to define the conditions over them. And to do so, we basically propose to use the same principles that are being used for synchronous services. So in synchronous services, there is the service level agreements, where the service level agreement, it is basically a contract between the service provider and the service consumer for the provisioning of a web service, and that specifies what are the conditions and also the quality of service that the service provider promises to their clients. And so there are several specifications, several languages to write service level agreements, but the de facto standard in terms of synchronous services is the WS agreement. And our goal is to use this same WS agreement in the field of asynchronous services, adapting the particularities that the event-driven architecture poses. So the WS agreement is basically a document that has this structure. So it has a name, it has a context. The context provides, for instance, who is the service provider, what are the services being provided, and it might also talk about, for instance, the duration of this WS agreement contract, and so on. And then we have the terms. The service terms provides the definitions of what are the particular in the field of synchronous services. These service terms will be the services, the methods of those services, the endpoints, and so on. And the guarantee terms is where we specify the conditions. In the field of asynchronous services, what we have is basically the services that provide events into particular topics and channels. So the concepts that we are familiar with in the AsyncAPI specification are the ones that relate to the service terms. And the guarantee terms are the ones that where we put the conditions that we must guarantee. Now the guarantee terms, it has several things to be included in that. So the first one is the service scope. So when you put a condition, this condition applies to a particular scope. In the field of synchronous services, the scope can be, for instance, that this condition must apply to these particular methods. In the field of asynchronous services, the service scope might, for instance, apply to particular topics, to particular channels. Or you might also state that the service scope is the whole asynchronous, what the whole asynchronous service is providing to the whole set of channels, set of topics. The second aspect is the qualifying condition. So this is some sort of a precondition that must be true in order to enforce the service level objective. So it's some sort of a precondition. It's stating that my service level objective, where I'm going to put my condition, should be true if the qualifying condition is also true. So for instance, we might specify service level objective that should only be applied during, for instance, weekdays, specific hours, or even we might also include here some conditions for some particular metrics. So for instance, if we want to enforce that the latency should be below a certain number, if, let's say, there are less than a certain amount of people subscribe to that topic, so this if would go to this qualifying condition. In the service level objective is where we put the condition that we want to assess. And finally, we might have optionally what is called the business value list. And here we basically can put rewards and penalties if when the conditions when this service level objective are not fulfilled. Now the question is, how can we integrate this WS agreement in AsyncAPI? That is the basics, the idea of our proposal. Now the thing is, in the field of how WS agreement has been defined, it is as a standalone document. So that means that, for instance, if you have a SOAP web service, which is specified in WSDL, or if you have a RESTful service specified in OpenAPI, the WS agreement is used as a standalone document. In our case, we believe that it was much more convenient to integrate WS agreement inside the AsyncAPI specification. So instead of defining a standalone document for asynchronous services, what we are doing here is integrating this WS agreement within the AsyncAPI specification. Now, how can we do that? The thing is, as part of our previous work, here you have the QR code if you're interested in the paper, we defined an AsyncAPI. So we basically extracted the AsyncAPI meta model. So here we have the UML model of the AsyncAPI specification with all the different elements of the AsyncAPI notation. And from that previous work, what we have done is we have extended this meta model with the concepts of the WS agreement. So here we can include, as you can see, the SLA with the guarantee terms, the scope that pinpoints to channels, The guarantee terms might be qualifying conditions or service level objectives, and they are basically Boolean expressions over quality of service metrics. And these quality of service metrics are the ones that we have seen, are the ones that are mapped, so to speak, to the elements that we have seen in the quality model. Here we have an example of an async API with this extension that conforms to the meta model that we have shown previously. So for instance, here what we do is in the components part of the async API specification, we add as a component the QoS metrics. So basically here we are defining what are the metrics that we are interested to put conditions over in this async API specification. And for instance, in this QoS metric, we can talk, for instance, for the average latency, we can put a description. And then the metric type is latency. This metric types is the list of the elements of the quality model for asynchronous services. We can include what is the unit that we want to put the conditions or measure. That could be, for instance, in millisecond. And also one relevant thing here is that we can group these metrics by event. That's something that doesn't happen for synchronous services. And the thing is that in asynchronous services, there is one event generated by the service provider, and this event is received by multiple service clients. So when we talk about latency, you might have several latencies, one for each service client receiving the message, or you can compute the average latency grouping all those messages by event. So if there are 10 subscribed clients to a particular topic for a particular event, you do the average of all these of the latencies of all these clients. And this defines basically the different metrics that we are interested in. Another important aspect that is different with respect with the WS agreement, since here we are integrating WS agreement with async API, there is no need here to repeat again what are the channels, what are the servers, and everything that are specified in the async API, because it's already here in the document. So here in terms of the terms, the service terms that we need to define, we only need to define the quality of service metrics. And then we go to the service level agreements, to the guarantee terms. Now in the guarantee terms, we can define, for instance, here the scope where our service level objective applied to, and here we can define our service level objective that we are referring here the average latency that we have defined here previously should be below, for instance, 300, and this 300 is, as you can see, in milliseconds. So this extension, we have developed tool support for that. And we basically had a tool that we started to develop years ago, which is the Async API Toolkit. Now, the Async API Toolkit is an Eclipse-based tool, and it provides an editor with content as is. It also checks the grammar and everything, and it has code generation capabilities. So we have basically recently in this work, what we have done is we have extended this Async API Toolkit with the new meta model that includes the WS agreement integrated with Async API. So here you can easily write and specify your Async API documents with all these functionalities that are provided through these instruments of Eclipse. If you're interested in the tool, you can have a look here at the QR code. And in terms of the code generation capabilities, one of the things that we are working right now is on the generation of monitors. So in the current version, what we have is that the code generation capability of the Async API Toolkit is capable of generating boilerplate code for MQTT. So basically, from the Async API specification, this Async API Toolkit is capable of generating both the server-side code and the client-side code, very simple, very boilerplate code that can be extended by the obviously by the developers of the service. And what we are doing is we are extending these code generation capabilities to also generate the monitoring instruments, in the sense that When you put the conditions that you want to be enforced in your asynchronous service, we are generating these also monitoring instruments that are instrumenting this boilerplate code that we are generating in order to monitor the different metrics that are here in this async API specification. So this part is still a work in progress, but the part about the specification of async API with service level agreement support, it is already available. So as a conclusion, we have presented here what is the quality model for asynchronous services, where we basically identify those metric attributes and characteristics that are relevant for this type of services. We have presented an async API extension with service level agreement support based on the WS agreement standard. And we have also briefly described the tool support that we have, the async API toolkit that provides this tool support to define these async API documents with this service level agreement support. So that's all for that. Thank you very much. And now it's time for questions.
Hey folks, I hope you can hear me well. Welcome after the break. I'm here to replace Ace because he ran out of internet. We'll send him a few buckets with internet later. So yeah, let me let in Marc. Marc, you ready to join the live stream? Okay, perfect. So
Hi. Sorry, I cannot hear you well now. I don't know if it is me, but I could hear you well before I joined. Now I cannot hear you well.
how about now? Can you hear me well?
Now better, yes.
Okay, perfect. So yeah, basically, thanks a lot for taking time to present, and the most important, taking time to show up at this late hour on Saturday. That's I'm super grateful, and I bet other members of the community appreciate it. And
No problem.
I think there are some questions for you. I think there's a question from Ravi. So can we apply SRE methods to Async API?
Okay, for us, RE methods, I guess it means site reliability engineering methods. And yes, obviously, I mean, of course, you can apply SRE methods to async API, and actually our contribution and our work could contribute in this field. So, for instance, the fact that you can define specifically what are the conditions that must be met in order to guarantee that the quality of service is adequate for your asynchronous services. And then, for instance, these things that we are working on, that is automatically generating monitors from that specification. So for sure, it can be applied. And our contributions aim actually at supporting or providing some support to these practices.
Okay, and I see that Ravi also mentioned open telemetry. Do you have something to add in case of open telemetry?
I haven't checked too much about open telemetry, but yes, basically, I guess it could be used. I mean, in the sense that the ASIC API specification is agnostic towards with respect to the technology, and in our extension, when we define these service level agreements for ASIC API, it is also technologically agnostic, so independent from the technology. The component that we are generating that is based on our previous tool to generate these monitors and let's say they are in-house monitors that we build here in Universitat Oberta Catalunya. But of course, I guess that we could, for instance, generate the components or the elements required in order to configure the open telemetry or any kind of monitoring systems that are out there.
Okay, perfect. Ravi, I hope that answers your question. I don't see any other questions. So Marc, do you want to add something at the end, like a wrap up or like summary, something super important people should remember from your talk?
So if you are interested, you have in the presentation the QR codes of the different elements, our papers, as well as our tools. And yeah, just glad to be here and be able to share with all of you our extension, our proposal to extend the Async API. And more than welcome if you have feedback or comments, or if you want to ping me in the Slack channel. I am more than available to answer or get in touch with you.
Awesome, thank you. And from my side, huge thanks that you're building also tools around Async API. Because like, yeah, spec itself without awesome tools is nothing really. So yeah, thanks a lot.
Thanks to you.
Okay, so yeah, see you around. And
See ya.
folks, so now it's time for a break. Let me so I'm really not in sync with schedule, so let me have a look. It's 5:55 in Poland. So the next talk is no, actually we have break in 5 minutes. So we're gonna have a longer break. Oh, we're gonna have a super long break. Awesome. Cause I just got fries from my wife, which is amazing. So we have the next topic will be delivered, like the next presentation will be delivered by James, and we have like 34 minutes break. So the talk is at 17:30 UTC. So James from VMware will talk about Async API and the worldwide, not web, flow. So yeah, see you around in half an hour.
And we are back. Hello, everyone. Welcome back. And I hope you guys are still having a good day and you're enjoying the talks that we are having. So, on our next speaker is James. He will be giving us a talk about Async API and the worldwide flow. James is with me backstage. James, can you wave your hand so I can bring you on stage? Perfect. Hi,
Hi, how
James.
are
How are
you?
you doing?
Hello.
Hello, James. How are you doing?
I'm doing good, thanks.
Thank you so much for coming today.
Yeah, happy to be here and excited to talk to everybody about basically a topic that came off of the book I wrote for O'Reilly called Flow Architectures, the Future of Streaming and Event-Driven Integration. Give you guys all an idea of sort of this concept that I think Async API can play a huge role in of the worldwide flow, which will be explained in some depth in the course of the presentation, so I won't give too much away. But yeah, excited to share it here and excited to be a part of this event.
Thank you so much, James, and I hope the audience is excited to learn more from you. Without further ado, we'll get right straight to the talk.
Thank you. Hi, I'm James Urquhart. Welcome to my talk today about Async API and the worldwide flow. And certainly hope everyone is doing well wherever you are in the world and whatever time it is. Really, the topic of this conversation is the idea of driving business, speeding up the flow of business through event-driven integration and basically integrating the communication of changes of things of activity and changes of state between organizations, and ultimately as organizations connect to each other, kind of creating a giant set of those connections, which I call the worldwide flow. I'll start by defining the term flow a little bit because it's a heavily overloaded term, and we all know that you can find that word used in tech in a million different places. In this case, I want to be very specific with the definition. I'm talking about flow in terms of an event-driven integration across organization boundaries, meaning either between from one business division to another business division within a company, but even more excitedly to me is from a company to another company, or a company to a government institution, or any of those sort of cross different organizational entity boundaries that might happen. And then doing this through standard interfaces and protocols, which we'll talk a lot more about here in a bit. But using standards so that everybody, it's as simple as possible to make these integrations happen. Now, the term WWF has a little bit of a history, at least in the United States, right? There's a big battle between the World Wrestling Federation, the Wrestling Entertainment Organization, and the World Wildlife Fund, which was this wonderful, peaceful protector of animals across the planet. So unfortunately, the letters WWF have a little bit of an overloaded connotation. But in reality, what I'm talking about is a concept that I go through in great depth in my book, Flow Architectures, the Future of Streaming and Event-Driven Integration. And really is encapsulated by this sort of tagline, right? As HTTP linked the world's information and created the world's web, flow standards will link the world's activity and create the worldwide flow. And I really think it has the chance of having the same or bigger impact that HTTP had on the way that we link what's happening in the world, who we are, the ways that we interact with each other in the world. Not to oversell it, but really, if you lower the cost of this integration greatly, you're going to create this explosion of new integrations that happen, and who knows where that's going to take us. And another way to picture this is really just in terms of EDA. So, here's Fran presented this earlier in the conference as sort of a very simplistic picture of an EDA. And I want you to kind of take a look at this and, think about this. Okay, instead of being within an application system and a very simple set of software services, what if it's companies? So imagine that the European Weather Center for Weather sends the predictions to DHL, a transportation company, and that transportation company in turn sends signals to suppliers, to manufacturers, to shippers, to say, hey, these are when trucks are going to be available. These are the capacity elements that are going to be available. This is what weather effects will have in terms of travel times. And then also at the same time can send signals to the consumers about, hey, your package may be delayed a little bit because of this weather event, or hey, we had really easy travel conditions, so we predicted this will be at your front door, in this 10-minute window period. There's a lot of other activities like this that you could imagine. Things in finance where people are exchanging information about transactions that have occurred, or movements in stock price and other things like that. Healthcare, there's the obvious condition, sort of tracking patient conditions and being able to set off alarms or react quickly or automate corrections to things when health deteriorates. But I think just as interesting are the signals that can be sent between healthcare organizations about available beds, about supplies needed, about the current state of and changing state of their emergency room capacity and their ability to handle new ambulance loads, right? So most of the time that may be very mundane. There's not much to do. It is what it is. But if there's a crisis, then that data may be very, very good at signaling that there's a crisis underway, and at the same time also enabling these organizations to coordinate with each other better and faster. I started this exploration by sort of asking the question, okay, if you're going to do flow, if you're going to do event-driven integration across organization boundaries, what are the pieces and parts that you need? And really a large chunk of what needs to be there is the stuff that's sort of more to the right? The sources and syncs, syncs database storage is readily available from any cloud provider in several forms as a managed service. It's just a utility pretty much at this point. Even the ability to process data or the queues that we use to sort of buffer event data and broker event data. Those things are sort of very, open source projects. Apache alone is, probably got 15 or 20 projects that kind of fit into the queue and processor space in some way. There's a lot of really, really powerful things out there that are kind of readily available. So the pieces are set up on the board for Flow to be out there and be successful. What's missing, though, is the stuff that's to the left. What's missing is the stuff that's related to the standard interfaces and protocols that are needed to make this integration as simple as possible. And so this is what I explored in the book, as sort of what would it take, what are the elements that have to be there, and what is the landscape today, and how will that potentially encourage the movement of these things. And so get a little bit more kind of definition of what I mean by interface and protocol. So protocols, we're all very kind of aware of sort of the wire level protocols, TCP/IP, and then on top of that, things like MQTT and AMCQ and all these different other things that are really critical that we use all the time. But packaging the event data itself is extremely important. On top of it, the thing that's carried by those protocols on the wire is very important. So metadata is just setting the context of the event. Not only where did the event come from, is it connected to any other events, but also things like, what does it take to be able to process the event? What's the format of the payload? What's the size of the payload? And what encryption is being used, right? There's all kinds of things that could be represented in metadata. And then the payload itself, which is, whatever the data is that we're communicating, this state change of an individual value, the new state of a complex set of data structure, whatever it may be that we're communicating. And then on the interface side, there's really two interfaces that I was able to kind of narrow things down to. So one is discovery, which seems like it's very kind of extra at first, but it turns out to be really, really important in order to understand not only that there exists a stream that has a certain type of information that you want to consume, but also what does it take to be able to consume that stream? How do you filter for information, or how much volume can you expect to receive? What compute capacity would you calculate off of that? Excuse me. And then there's the subscription API, which is sort of what everybody, thinks about right away, the subscription interface, right? So, which is really important to allow a publisher to say, hey, I'm making this data available, and allows a consumer to say, hey, I want to connect to that topic, maybe with this filter, and I want to be able to consume that data. And by the way, to authenticate that they are who they are, and that they're allowed access, and so on. And some examples of that then, and sort of really narrowing down on kind of how close we're getting here. So we've got standard wire protocols all over the place. MQTT, MQP I talked about. Web sockets is really big. And increasingly I see that out there, especially for point-to-point connections when you're not going through a broker. There's also the metadata, and I really think, and I'll make the argument through the rest of this talk, that Cloud Events really has the inside track here. It's just by far not only the best expression of the metadata required, I think by far, but also the most used and utilized by vendors and cloud providers and so on. So it's really got kind of it's beginning to be adopted very quickly. Then I think for the payload, my belief is that ultimately the standards in payload are going to not be sort of general standards, but are going to be specific to industry. So, it may be, embedding fixed financial transaction information into a payload. It may be, healthcare related. It could be custom protocols that get built by, say, a small group of vendors that are working together in a special way to accomplish something. And it may be options that we can't even imagine today, right? There may be government-defined payload standards for certain types of transactions or certain types of information exchange. We don't know, but the payload has to be flexible enough for all these different kinds of things to be represented as they need to be represented so they can be consumed. And then the interface side, I really think AsyncAPI, all the evidence I have points to AsyncAPI having the inside track. And I say that, and I'll explain more in detail why in a second, but really the big things here is AsyncAPI kind of combined with a number of things is something that allows you to get to the AsyncAPI documents, to discover the AsyncAPI documents. It's really like a self-contained set of information that's consistently communicated, right? So you can get a description of the API fairly easily. Now, how do you find those AsyncAPI files? Well, that might be somebody sets up a registry service or something like that. I think, personally, the most likely thing is that people will kind of make them available on just developer websites somewhere, right? And people will Google for them. Google will be the primary search mechanism for the discovery. AsyncAPI will be the representation of the API that is either machine or human consumable out of the result of that. It's all, again, speculative, but I think there's a solid evidence that at the very least AsyncAPI docs have a very likely chance of being a part of that. And then subscription, AsyncAPI, again, I see that way more than anything else that's out there. There is other options, simpler, more specifically defined for PubSub, for instance. So the PubSub API from Salesforce is the example I give here. There's some, the EventBridge API, there's the Google PubSub API. There's other things, Kafka API, that could potentially kind of win out for the subscription API, but I really think it needs something like AsyncAPI that's more general, more adaptable, extensible. I'll talk about this stuff a little bit more here in a second. Now, one of the things you can do with these Worley maps that I've been showing you here is you can begin to think about, hey, if everything's sort of being custom built or it's product based or whatever now, what happens if, as the industry begins to mature that technology to the point where those things become basic commodities? And so it's especially interesting that all that stuff that I had circled on the right before is all needs to evolve. This is the opportunity. This is why there's a door open here for a standard to appear for the interfaces. So async API plays the role of interface really well. It's a way of describing topics and connections. It's exactly what you need, right? Here's some information about it. Here's the the servers you can go connect to. Here are the channels that are available on those servers. Here are the components that are described, the elements that are described as part of these events. It's solid. I mean, this is the 2.0 spec. I know there's some changes coming with the 3.0 spec, but the basic pattern here and what we're learning as we implement these patterns leads to a really good way of sort of a basic description of what the API is for the interface to a flow service of some sort. I also like the fact that so far it's fairly consistent, right? We've got some major releases happening at a fairly good clip now. Hopefully with 3.0, third time's a charm, we begin to slow down kind of the major changes to the way things work. But it is something that has a solid community around it, has vendors that depend on it. That consistency is almost going to become guaranteed by just the momentum that's created by its usage, and the fact that breaking changes will be harder and harder as we go forward. It's also very adaptable, which is incredibly important, because who knows what event-driven integration is going to look like 20 years from now. It needs to be able to be extendable. It needs to be able to, there needs to be a process by which the standards can change if they need to change. And that will help it live longer and be important and survive as a standard for a long time. It's also discovery friendly, which I talked a lot about in a little bit earlier, but that's just a super really cool thing to add into it. It's also, and this is maybe the most important reason why AsyncAPI is inside track, is it's getting adopted. It has a community that's consuming it. It has the usage of these different vendors, these different implementers of AsyncAPI that are happening. And as that grows, as the number of organizations that are using AsyncAPI grow, and as they begin to offer those connections to other organizations and use it as a flow standard, that's how something becomes a standard in the modern era. You don't just declare it as a standard. You have to go get people to adopt it and validate it. Running code wins, right? And so you can say some similar things about cloud events as well, by the way, and it's important to kind of note them, right? So first of all, it's a way of describing perfectly, near perfectly well, the metadata of an event. It's really well thought out. There's been a huge amount of time put into it, a huge amount of kind of experimenting with different ways of doing things. And ultimately, it boils down to a very few required elements. These 3 elements on the left are the only required elements in this list. And then a whole bunch of stuff that can be added or extended in the definition of the metadata for that object, which all this makes it consistent. There's a community and a standard document and a way of updating the standard that allows the community to kind of move along together as a group. And it's extensible and adaptable to what's happening. But the big thing with cloud events is really nice. It also adapts to different usages of events. So you may have some systems that have a Kafka-like story where they need a connection of events that are related to each other, and that dependency is understood so that you can track through that as you step through the topics and sort of, rewind and play through it again. But others may just be sending a state change that's captured by a digital twin model that just essentially forgets when it captures that state change, records it, and says, okay, next event. And that connection between events is much less important to the way that processing happens. And it works really well with Lambda events, and it works really well with, there's this huge list of stuff, of types of processing. In fact, in the book, I have a really good diagram that kind of explains what are the different types of processors you use for different ways you want to consume events. And Cloud Events adapts to all of it. And that title is wrong. That should say Cloud Events. Also, by the way, why Cloud Events? It's being adopted, right? It's their implementation out there. This list is just a very small partial piece of what they have on their website, indicating people who've actually built integrations that use cloud events as the metadata packaging for the events that they either transmit or consume. There's a great list of vendors that are involved in the working group that is maintaining the standard. There's a great list of vendors who have come around and integrated some form of adapter or core functionality of their system that is cloud event aware and cloud event friendly. And you have things like Knative that make building platform elements that can consume those events much easier. Just eliminates a huge amount of the toil required to be able to capture and interpret those the metadata in order to present the payloads correctly. And I think really then you have to kind of look at what happens when you bring those two together. And this is what kind of excites me. Again, we want to go back to this idea that we want to make it super easy for everybody to connect into this web of streams that's available out there. And so so bringing cloud events and AsyncAPI together kind of gives you, I think, that proper collection of the right extensibility, the right separation of concerns to be able to enable flow to happen. And there are a few areas where there's still some overlap. Certainly protocol bindings like MQTT and AMQP protocol bindings, but both sets of standards generate their bindings. There has to be some reconciliation around that. But for the most part, really well set up to happen. And you can hear our discussion. This is a friend from the AsyncAPI side, Clemens Vasters representing, from Microsoft, representing the Cloud Events group. And then myself sort of representing the Flow architecture author. And kind of talking about these ways that these things can work together to create that flow future. What's the opportunity then here? And I think this is the most exciting part of this whole thing is there's a ton of opportunity. So first of all, AsyncAPI becoming part of CNCF, what a just a wonderful collection of technologies to bring together. And I think it really simplifies the ability for these working groups to get together and have these conversations about how can we facilitate a solution to these forms of integration as they become more aware and more obvious. And so, and I think, I've talked to the guys at Nats that work on Nats a few times about this. They're very open. As the flow standard appears, they want to make sure that Nats supports it very well. And I know that the API community could really use not only what AsyncAPI is doing today for all forms of event exchanges, but as we get into to doing these flow exchanges, I think it's going to be incredibly important to get to get the API community what they want in a way that they can consume it easily today. So again, really well set up. Some usability things that are missing, right? We don't have that way of just sort of saying, hey, here's a topic, I want to connect to it, right? There's no libraries that really bring AsyncAPI and cloud events together yet into a just super easily consumable piece. We do, some code generation stuff, that's great. And I think that work is really important. But I think there's no sort of like, hey, it's just built into a programming language, or it's just built into an operating system or a framework or whatever. So we'll see. I think some of that stuff started to happen as sort of the flywheel of demand and need sort of starts to spin out. Security authentication, I think, is still not, doesn't have quite the spotlight it needs. I think it's probably the most important problem that really needs to be solved well. And I know there's stuff about that in AsyncAPI. I think, just real clarity in terms of, especially if there's other standards that are being consumed, and sort of highlighting that the secure way of connecting in a standard way is really important to building trust in a commercial setting and in a government setting. And then adoption. We just need to make it as easy as possible for people to adopt Flow. And initially that's going to be a little bit rough because we don't know what all the pieces are yet. We haven't got it all working together. But I think in 5 years, the goal would be really good to say, look, we want to make it super simple. If somebody, wants to write an application that they want to connect to a flow compatible stream, that it's super simple to do it, and here's all the code ready to go to do it, or here's the library that does it for you, whatever that may be. So adoptability, onboarding is really important. And then some future opportunity here that I think is super, super exciting, right? So I maybe longer term than some of the others here, like monetization is one that I look at, and like, it's not just how can I charge to let somebody connect to my stream, but are there ways to charge for people to share that data with others, or to charge people to take, to license a piece of the data that's in there for use in other purposes entirely, or to pass it on to, whatever it may be, process it in certain ways. There's some exciting possibilities there. I think observability is a really hard one. Not only how can I see the things I control, but how can I see where my data is flowing outside of my control? And lots of questions about what's privacy, what isn't, what's trade secret, what isn't, that have to be answered there. But ultimately, I think there's a great opportunity here for being able to visualize how your activity is triggering activity elsewhere, or what you're waiting for, whether you're getting accurate information from a source, and you're getting all the information you should be from a source. Where did all this data come from, right? And then that brings me to provenance. And I really think the next billion-dollar company that comes out of EDA is going to be somebody who really kind of solves core provenance. Not only who is the origin and can I validate the origin of the data, but is the data as I receive it still as it was intended to be sent? Has it been altered in some way? Has it been added to in some way that's unexpected? And also, as this data moves through kind of multiple, it gets maybe posted in a different topic for some by a different party, whatever it may be, that kind of the core origin of each of the data elements is in some way validatable as having come from the source as a part of that event context. So provenance, everybody I talk to in the spaces, that's one of the biggest problems, is how do I solve the problem of making sure my data provenance is understood, and that I am not working off of some mocked data or malicious data of some sort. And with that, I think I'll wrap up and just say thank you very much. Again, opportunity is huge here. AsyncAPI very much has an inside track. It's a really well-designed standard for the purpose. I hope the 3.0 stuff takes it even further. I'm going to be very excited to kind of watch what happens with that. And then, but ultimately, where we want to get is, again, that ability, if we can make it super cheap for people to consume events from other organizations, there's a whole bunch of things that I think, I certainly couldn't imagine that can come out of that. Some bad maybe, but mostly good, and mostly really fundamentally changing the speed at which business happens on the internet. So thank you very much.
Yeah, so James, are you ready to come up? Hi.
How are you?
Yeah, I'm doing great. What an amazing presentation, James. So I really enjoyed your session. To be honest, it was amazing. I learned so much about how the flow, what it's all about. And yeah, I think you actually answered a question on Slack, right? But I would love to make you answer the question also on this live stream. So I'm gonna read a question to the audience now. Yeah. So Ravi asked a question saying, are you considering AsyncAPI to replace EDI/AS2?
Yeah, so I think there's a number of existing data exchange pieces that are largely used to push state change data across the wire. And EDI is probably the biggest one that everybody knows, but there are standards in the insurance industry and the healthcare industry. I put some of them in that slide where I talked about FIX, for instance, in the financial industry. And absolutely, my argument would be, if it is way easier, cheaper, and reliable to connect to a stream of that real-time data by the standard that everybody knows well and uses well, known to be secure, et cetera, that it opens up ecosystem, and it reduces, risk of obsolescence and a number of other things by moving to that standard, as opposed to sticking with something that's very custom for a given industry. Now, it will take a long time. When something really works really well for an industry like FIX, it may take a really long time. But if the ecosystem of stuff that could consume your event explodes, especially for things like routing, security, monetization, all that kind of stuff that's not specific to that industry, then I believe that there will be an impetus to make that move, so you can take advantage of that ecosystem of capability around the standards as we move forward. And it could be, I use the weather stream as an example. There's a lot of data that you think is very specific to a certain kind of class of problems, and it could turn out to be really useful in a place that nobody ever guessed before. And so if it's some special specific to an industry standard that data is available for, and everybody's got to go find it and figure out how to program to that, then that's really expensive. Whereas if somebody can just say, hey, I'm going to point to that stream and start receiving stuff and see what I can do with that data, the experimentation allows for a lot of innovation to happen much faster.
Interesting, James. I love that. And to add, right? So you actually, I think your session with Fran on the Taking Out Loud episode was one of my favorites, right? So you were in the session with Clement, and I see you guys talk so much in depth about AsyncAPI and cloud events and all sort of stuff, and I really love the session. So shout out to that stream. So if you haven't watched the live stream about Taking Out Loud, where Fran hosted James and Clement. So I'm gonna share that in the link after the short break. Right. Thanks for joining us, James. I'm looking forward to having you in the next conference.
Hey, I really appreciate it. Thank you, and love the show. Lots of great presentations. Thanks.
All right. Have fun, James. See you.
Thank you.
Yeah, welcome back. So thanks for hanging in there, folks. So finally, we are currently at the last session of the AsyncAPI Conference 2022. And yeah, so excited. It's been a long ride. And yeah, I'm so happy to be presenting the last um, presenters for today, and which they will also be the last presenter for the AsyncAPI Conference 2022. And with me here, I have amazing folks, Natalie and Rob. So, are you guys ready to come up stage? Can I get a thumbs up? Oh, awesome. So, bringing you guys up stage. Hi, guys.
Hello.
Hi, Natalie. How you doing?
I'm doing good. I'm doing good. I'm wondering if things are pretty slow. Oh, looks like Rob might
Cool.
be having some audio
Rob.
issues.
Yeah, I'm checking in with
He'll
Rob
be back,
now.
I'm sure.
Okay. Yeah, definitely. So I think Rob is back.
Yeah. Now my mic works.
Awesome. Hey Rob, how you doing?
I'm great. How are you?
Yeah, I'm doing great too. I'm so excited to having you guys here with me today, and very interesting. You know, you guys are the last presenter for the AsyncAPI Conference 2022, and you know, I can't wait to actually get right into it. So, how are you guys feeling now?
We're
Great.
great.
Yeah.
It's been a awesome conference.
Awesome. So before
recording, everything was relaxing. So
great, and we're looking forward to do way more better next year. I know with amazing folks like you guys, will definitely be more better next year. So before I play before I play your video, your presentation, would you like to share anything?
not really. I think we walked through it and set up the context, and we don't want to give away the surprise. I will mention that there's like a fully functioning demo you can use to, short of it is you generate full async API specifications from data instead of ahead of time. It comes at the end, and there are links at the end you can use to try it out yourself. And there's a hosted service, just like an endpoint we have, where you can be like, how well does this really work? And you throw your own data into it. And there are links at the end. So we encourage folks to try it out.
Oh, awesome. I'm definitely gonna try it out, man. For real. I'm doing it. So for folks that are actually watching this live stream from everywhere around the world, so you should feel free to do whatever it is Rob and Natalie has for us after this session. Okay, playing the video now.
Hi, my name is Rob Galanakis.
My name is Natalie Edson.
We're the founder and senior software engineer at WebhookTB. Today we have something fun to present, at least we hope it's fun, definitely a bit different than many of the other talks. We're going to build a complete and comprehensive async API specification without writing a single line of it ourselves. So let's set the stage. There are two things you should know. First, about our company. It's just the two of us right now. We'll talk about our product, WebhookDB, in a minute, but we also run a software consultancy, Lithic Technology. We're juggling clients and customers and support and life. There's always quite a lot going on.
The second thing that you should know is that we're pretty lazy. Lazy, of course, meaning that we want to spend time doing things that we enjoy doing and then avoid spending time doing things that we don't enjoy doing. I'm a published poet. You can see here in these pictures me reading at a poetry reading. Rob is the primary parent to his two children. You can see Rob here being very silly. Thankfully, we also enjoy programming, but when we do program, we like to really let our creativity flow. We're not specification people.
On top of that, I'll come out and say I'm not a huge fan of code generators. I'm also skeptical of any technical documentation artifacts I run across in version control, and my eyes run right over this sort of specification language that reads like someone's lecturing a misbehaving child. There's no question, though, that specifications are absolutely vital to the world of programming, and I'm very glad there are people that enjoy building them. Just because I do not is not a criticism of specifications as a pursuit. But it does make us very strange speakers at a conference designed around a specification. Like, how did we get involved with AsyncAPI in the first place? To answer that, we need to tell you a little bit about WebhookDB, our software product. I'll keep this short since this is not a sales pitch. WebhookDB is a self-hosted or fully managed data reservoir that instantly synchronizes, schematizes, and normalizes data from third and first-party APIs and can be queried using SQL. Or put another way, we take data from APIs, jam it into a Postgres database so it's normalized and structured, and then you query that database.
The biggest challenge of an integration product like this is the sheer variety of programmer expression that exists. Every time we start a new integration, we have to be prepared for anything. No documentation, examples, or staging environments are ever complete, and many APIs lack them entirely. This is a particular problem for WebhookDB because we also support what we call the API 99%, which is the long tail of companies that offer APIs as an additional thing rather than their main product. Integrating your Stripes and your Shopifys isn't so difficult, but most APIs aren't up to those standards. This, for example, is part of an actual payload from an API we support. There's a lot going on here, and it's trickier than it seems at first look. Like, you can't really tell what the start date and end date refer to in terms of AM and PM. You can only know for sure by seeing more data.
So every time we have to integrate an API, we'd have to carefully go over documentation and examples, implement based on that, hope everything's correct, and tell me if you've heard this one before, continually find out all the ways the production API differs from what's documented. But we're lazy and a small company, and I don't like fixing production issues at my kids' soccer practice, and we like building silly but sometimes useful stuff. So we stepped back and said, is there a better way? Yes, there is. Well, maybe there is. What we realized is that instead of integrating an API and then testing it live, we could capture a bunch of data from production and use that to drive the integration. From there, we realized it's actually quite difficult to understand an API by looking at 1,000 different individual API requests. We needed a way to classify them. This is what led us to AsyncAPI. Instead of using a specification to drive and control the development of a service, we could use it to classify and describe a service that already exists. That is, we could feed individual requests into a program that generated an async API spec even before we started writing a real integration. And then we decided we could use the specification to create fixtured events and publish them against WebhookDB as a way to regression test every single one of our integrations. It was a real aha moment that instead of using the spec to circumscribe development, we could use it to explore unfamiliar systems and navigate how we integrate with them. This could bridge the gap between the highly structured procedural world of specifications and the freer flowing, more artisanal style of programming that we like to do. So we set out to build a tool that could accomplish this for us.
To do this, we depend on cutting-edge techniques across the disciplines of machine learning, genetic programming, multivariate statistics, and formal proof modeling. Just kidding, it's a lot of if statements. The tool we built is called Mox Populi, or MoxPop for short. When we think about authoring specifications, there's normally a central group that makes decisions, and then it is up to other devs to ensure that their services conform. MoxPop flips that on its head. The implementation is what drives the specification. MoxPop generates specs for how your service integrates with an external service. This perspective has been important for us while working on WebhookDB because we're working primarily with third-party APIs that don't have formal specs and cannot be modified. Here's how all this works conceptually. Events are published by external services on the left to your service in the center. When you use Mox Populi to build a spec for your service, these events end up describing subscription messages. As events from the external service are handled by your service, you sample and record them at full fidelity. Those recorded events get fed into MoxPop, which generates async API specifications and then incrementally improves them using newly recorded events. Finally, you can use those specs to generate fixtures that you can publish back to your service as part of integration tests, or to generate data for unit or fuzz testing.
That was a lot, so let's break it down into 4 steps. The first step is recording events. Then we use the recorded events to generate JSON schema for message payloads. Then we use the recorded events to generate the rest of the async API spec. And finally, we turn generated specifications into fixtured events and publish them to our service. This first step is the most straightforward. Capture full fidelity events in whatever format they're being published. For example, if these are HTTP events, you'll need to capture the method, URL, headers, and body, even if you think you only care about the body. If you've captured enough information so that you can replay the event, you did it right. Also, you'll probably want to sample the events you capture. There's no reason you'll need to run moxpop for each event.
Step 2. Generate JSON schema for message payloads. This is where moxpop enters the picture and things start to get interesting. In this step, we're not actually focused on async API. We're just focused on JSON schema. We take a JSON object and generate the JSON schema that describes it. Now, without using moxpop, here's the JSON schema that we would expect. On the left here, you can see we have 2 different integers. From our experience as developers, we know that these integers probably mean very different things, but in the schema that gets generated, they're both described in the same way. So the schema is very accurate, but it's not very precise. To generate schemas that we can use to generate fixtures, we need to be both precise and accurate. These targets from left to right show low precision and low accuracy, like a JSON schema with just a type, which is what we just saw. It doesn't provide much detail about anything. Then we have high precision and low accuracy, like if we generate constraints that are wrong. Low precision but high accuracy is like if we use the format property. Knowing a string is in a date format is useful, but it doesn't tell us anything about the actual date being represented. And finally, we have high precision and high accuracy, whatever that means. We need to achieve high precision and high accuracy. That's what moxpop schema generation is all about.
This is where we start to get creative. We can use async API extension properties to provide a new layer of precision to the data we've seen. Using moxpop, this is the JSON schema we'd end up with for the previous example. You can see here that we have an extremely high level of precision, but probably too high. We've made a lot of assumptions. These assumptions are likely to drive down accuracy. We assume x will always be a 32-bit integer, and that z will be an integer and a timestamp. We can't know these things for sure, though. It's very likely we're wrong about one or all of the assumptions we've made. So, in order to improve accuracy, we can generate schemas for many payloads and merge them together. This resulting schema has a decreased precision, but increased accuracy. For example, what we thought was an integer may actually be a floating point number, or could be a string in some cases. We keep fitting the schema to the data we see. The fitting process is commutative, so we can keep doing this incrementally as we record new events. The resulting schema will always be accurate for all events ever processed.
However, there are a few cases where we can't be precise at the beginning. For example, if we get a random string of ASCII letters and numbers, we can't tell what it is right away. It might be an identifier or maybe a free-form text entry. In these cases, moxpop will store and accumulate the values we observe in each payload, as we see on the left here. Eventually, after we've sampled enough data, we can make a decision about the schema. For example, if every value we've seen has the same length, and they'll seem like identifiers, we could assume it's an ID field. We do the same thing for enums. At some point, we've seen enough samples and seen few enough distinct enum-like values that we can assume the field is an enum. These enum values get put into the enum JSON schema property.
Recording information in the xSeenValues property is tricky because there may be sensitive values we don't want to include. Sometimes access tokens or IDs come through in an event. Whenever we get a string value that looks like gibberish, we generate a new string value of the same size and use that so that we never write out IDs, tokens, or anything else sensitive.
One last thing MoxPop does is record copies of payloads into the examples field. This allows you to see actual event payloads in this spec. We try to be clever about when we collect them, like when a property format changes. Being selective about examples bridges the gap between reviewing the API in the abstract only through the specification and reviewing it only through live events. You get the best of both worlds. The API is condensed into a spec, and every example shows you some unexpected change vector.
So putting it all together, here are some of the formats and properties MoxPop handles. You can see full examples in the GitHub repo. The version here uses a superset of AsyncAPI and JSON schema formats, plus some formats describing data we've seen in the wild, like numerical strings and integer timestamps. These additional formats, coupled with the constraints in the scene values, give us an accurate and precise description of the data we see from an API.
So the previous step was all about generating JSON schema for payloads. We're going to take the same idea and apply it to the rest of the AsyncAPI specification. We can actually generate most of the spec from the full fidelity events we record. We can't handle sections like info that require out-of-band information, but we can do quite a lot. I'll warn you here that the examples in this section are HTTP specific. Because WebHookDB is focused on webhooks, most of our usage is HTTP based. All of these examples should work for other protocols, but we wanted to warn you as we'll be using HTTP specific terms ahead. We can take each component of the HTTP event and figure out what parts of the spec the component applies to. Path, method, and body map directly to channels, channel bindings, and message payload, but request headers are more interesting. The HTTP request headers map to multiple parts of the spec. We categorize headers into special, protocol, and application headers.
Special headers are those with a special purpose. For example, host and accept can be used in the server object, describing the server URL and protocol versions. The content type header sets the message content type, and we can figure out the message correlation ID by guessing which header, if any, looks like it's the correlation ID. For protocol headers, we keep a list based on HTTP standards. Any protocol headers are set on the message HTTP bindings headers, as in this example. We include the actual header value in the JSON schema, so the spec is easier to understand. Protocol headers, as you may guess, can't really be fixtured since the value is meaningful for the protocol. In these cases, we end up ignoring them or using the X last value verbatim.
Finally, anything we don't identify as a protocol or special header, we treat as an application header. For application headers, we use the standard MoxPop deriving and fitting, so they get as much fidelity as the message payloads. When you put this all together, we can take some recorded events and generate a totally usable and valid AsyncAPI specification. You can see the full example in the GitHub repo, which is linked to at the end of the talk.
All right, we're finally at the reason we built MoxPopuli in the first place, which is to use the generated AsyncAPI specs to fixture and publish a huge number of events against the service. There are two types of fixturing going on, and here's the first one. MoxPop can create fixtured objects for the JSON schema we saw generate previously. It uses all the extension properties to make sure the fixtured value looks pretty close to real. There's obviously a lot of fake data here, but from a technical standpoint, this looks legit and probably exercises the same code and database paths that real data would. The detail in the fixtures comes mostly from the number of custom formats, which we saw earlier, but also the extension property fields act as constraints that narrow down the fixtured values. For example, if you have a created field that's an integer timestamp, all the fixtured values would be between the minimum and maximum that's been seen in any recorded event. You won't get created values from 20 years ago or 20 years in the future.
Finally, here's what happens when you run a regression test against MoxPop Vox and your service's AsyncAPI spec. It publishes the configured number of events against a server. We use this fixturing to both load test and integration test our backend. What you see here is the request and response dump of a fixtured HTTP request sent to the server and the actual server response. Again, you can see we're getting pretty nice fixtured data, and the server accepted it happily. So what have we learned building MoxPopuli? 3 big lessons.
The first is that Async API truly can describe any kind of API. This was our first time using it, and we were super impressed. I've done pretty extensive work with the OpenAPI, and Async API has some subtle and significant improvements. I think all of them are great. I know I'm preaching to the choir, but I did want to mention it and affirm the amazing work so many folks here have done. As outsiders to the world of specifications, this work all gets a huge thumbs up from us. Our second takeaway is probably what you started thinking a couple minutes into this presentation. Building MoxPop was a lot more work than not building it. While it's been useful, I wouldn't say it's been essential for us at WebhookDB, at least not yet. We do expect this to change as it's developed further, and we get to lean on it for more and more new integrations. We may have been able to solve some of our problems with other tools or with a little manual labor. However, and this is a big however, the third takeaway is whether or not it was worth it, building MoxPop was a whole lot of fun. Software development at scale is frustrating and stressful. I don't have to tell all of you. And two of the best ways we have found to make it more fun are to build better automated testing and tooling and to work on tightly scoped projects that allow us to be creative within that scope. In the case of MoxPop, when your project is a tightly scoped testing tool, that's the best of all worlds. MoxPop helped fill out integration testing around WebhookDB, and it was a ton of fun to work on. This is largely because Async API is so well done from the spec to the tooling to the documentation and the community. I really can't say enough good things.
Thanks so much for watching us today. You can go check out MoxPopuli on GitHub. It's a Go project you can use as a CLI or a library, but even better, there's a link in the README that allows you to try this whole thing out yourself using curl. Really, you should go grab some events from your own services, run them through the endpoint, and see what sort of Async API spec you end up with. We hope it's as useful to your teams as it has been to ours. You can also reach Rob and me via email if you want to follow up. We're happy to answer any questions or just talk shop. Finally, if you're dealing with any third-party API integrations, you should check out WebhookDB. And if you're ever in Portland, Oregon, please let us know. We'd love to buy you a coffee and tea or just chat. Thanks again to AsyncAPI Conf. This has been great.
Hey folks, what an amazing presentation from Natalie and Rob. So I'm bringing you folks back up. Are you folks ready? Great, coming up. Hey guys, come back.
Hey.
So I can say Rob has the better version of himself. Oh, where did she go? So is he gonna be representing you, Rob? She's gonna be answering some questions.
Yeah. She's all brought up to speed.
That's awesome, Rob. So you guys just gave an amazing presentation, and I absolutely love it. And yeah, but I have a question, right? So you said you have some experience with open APIs, but of course I think API is far more better. If you can say it, I can say it, right? So I think API is far more better in my opinion. But so are you saying even if I want to document, if I want to generate for RESTful APIs, I'm still going to get my results in the Sync API specification, right?
Yeah, so as part of building, so I mentioned before the presentation, we have just like a hosted service that basically just runs the CLI for whatever your request input is. In order to build the Swagger for that, I went into or OpenAPI 3.0 for that. I went into a project I built a couple years ago. And I was like, oh man, I can't use OpenAPI. There's so much complexity to it compared to Async API, which I've done a lot less work in, but just felt that it was so much easier to use that if I were to go back, we build a lot of APIs. We don't do a ton of like enterprise type of event-driven architectures. But if I were to just build a spec for an API I was building, I would do async API and then just rely on people understanding, it's a request response. I mean, you can document the request and response and everything, but it handles everything and handles it super well.
Interesting. I love that. Because technically, I've been in these kind of conversations where I keep telling folks, you can use async API to also with RESTful APIs, right? Even though its main idea is just for event-driven APIs, right? But I can say it does everything, right? So why can't we just use it instead of which is an open API, just have everything in just one single place. But yeah, I still say folks telling me, just to use open API for RESTful purpose and just use event API with async API. And I'm like, why not? We could just use both with async API. So based on that, would you suggest folks just focusing on async API for both their RESTful purpose and event-driven purpose?
Yeah, I would just stick with async API for documenting RESTful APIs. I don't see a compelling. There's nothing that I see in open API that I am unable to represent effectively with async API.
Oh, great. So I don't think we have. Okay, I think can we hold on the page to see if we have any question for you on the channels? Let's see. Okay, it seems we don't have any question. So I'm so excited to to be the person to host you guys. And you guys gave an amazing presentation, and I can say you guys are very, very awesome. And yeah, so I will be working, like I'll be testing out these amazing tools you guys have built, and maybe create some content around it to also share with the community about an amazing stuff that is actually going on with people that are helping pushing the Async API initiative forward with such tools. And yeah, I'm looking forward to doing that and also collaborating with you guys. And I can't wait. I can't wait to do that.
Excellent. It's been a pleasure.
I think that's of course, definitely. So I think that's everything. So do you guys have anything to share before you guys say goodbye?
Just thanks for the opportunity. Yeah, this I think Mox Populi is fun, so I hope you guys do too.
Same.
Of course, looking forward to the future of your webhook, DB, and I'm pretty sure the future is exciting. And yeah, so we as a community also are here for you guys. So looking forward to seeing you guys next year at the AsyncAPI conference. I'm pretty sure by next year you guys would have some amazing features to like demo for us. So, all right, bye guys.
Bye bye.
So we just had a wonderful session from Rob and Natalie, and yes, that would be the end of the AsyncAPI conference 2022. That's the last presentation. But Herman, it's been a long run. Since the last 2 days, we've had amazing presenters and we've learned so much. Personally, I've learned so much, and I've had so many ideas for some stuff for me to work on after this conference from the presenters. And I can see people doing amazing stuff, building amazing tools with Async API spec, and also so much community support from the Async API community. And yeah, so before we call it a day, I'll be bringing an amazing person. I know you folks have seen her face so much on stage. So Tuli, you up?
Hey, Ace.
Hi, Tuli. So
I'm back.
I'm so glad, for your contribution. And you did amazing for this conference. I'm giving you that. I'm giving you a 5-star. And I'm so sad to bring up not being able to bring up Ben, because Ben has to go. It would have made sense if the three of us were here. So for folks watching this live stream, Tuli did an amazing job being, I think she's I wouldn't say one of the best. I would say the best host so far for the AsyncAPI Conference 2022. She did an amazing job. Shout out to you, Tuli, at off. So would you I would love you to give a closing remark for the AsyncAPI Conference 2022.
Okay, this has been fun. I love the community. I love the speakers. Everything was so valuable, and everybody has been giving us, they've been dropping nuggets after nuggets after nuggets. And I'm sure everybody who has been watching since day one will benefit from each and every speaker that is spoken on this platform. So, yes, shout out to the organizers, to the community, the people off stage. Shout out to them for being behind the scenes and making sure that everything rolls for us on stage as well. So, big ups and kudos to everybody who made everything possible and flow.
Yeah,
Are you
so thanks,
still?
Tuli. So I would also, can you hear me?
Yes, I can hear you.
Hey, that okay, awesome. So as Tuli has given us a closing remark for the SyncAPI Conference 2022, and I think this has been a long and fun ride. So much knowledge shared, so many stuff. So Tuli has given a long shout out to the amazing folks that made this conference possible, and I will also be adding an additional shout out to the amazing folks behind SyncAPI. So many, I don't even know what to call them. I think they are superheroes, and they deserve a cape, right? So I'm bringing you guys a cape. You guys did awesome, and yeah, so these, I don't know. I don't want this conference to end, but we don't have a choice.
Yes, all good things have to
We don't
come to an
have-
end, unfortunately.
yeah, generally it comes to an end. All right, guys. Looking forward to seeing you guys next year, and I'm so hoping the Asian Japan next 2023 conference would be hybrid, so it would be in person and also online. And yeah, so if it is a person, then I get to have that beer with Fran. Um, so looking forward to seeing you guys next year. Bye, guys.
Thank
Peace.
you so much. Peace.